Close your eyes and let your body grow still. The world you know, the cities, the roads, the coastlines, the deserts, the mountains, is not the world that has always been. Beneath the oceans lie drowned continents. Beneath the deserts lie ancient riverbeds. Beneath the ice lie forests. The earth has worn many faces, and most of them are gone, vanished so completely that only the stones and the sediment remember them. Tonight, we go back. We go to the worlds that were real and are no longer, the landscapes that existed and were erased, the places that the earth has quietly, patiently buried under water and sand and time. Welcome. This is Explore During Sleeping, and tonight, the world itself is what was lost. Fact 1. Doggerland, the drowned world between Britain and Europe. Beneath the grey waters of the North Sea, between the coastlines of Britain and continental Europe, there lies a world that was real and inhabited and alive. A world that human beings walked across, hunted across, buried their dead in, and built their lives upon for thousands of years. It is gone now, swallowed by rising seas at the end of the last ice age, vanished so completely that for most of recorded history no one knew it had existed at all. Geologists and archaeologists call it Doggerland, named after the Dogger Bank, a shallow underwater sandbank that marks what was once high ground in this sunken landscape. The story of Doggerland is, in the most literal sense, the story of a world the sea erased. During the last ice age, roughly 20,000 years ago, so much of the Earth's water was locked in enormous ice sheets that sea levels worldwide were approximately 120 meters lower than today. What is now the floor of the North Sea was dry land, a vast, low-lying plain of rivers, lakes, marshes, and gently rolling hills, connected seamlessly to what is now Britain on the west and to the European continent on the east. Britain was not an island. It was a peninsula extending westward from a territory that stretched unbroken from Ireland to Russia. The English Channel did not exist. The Thames, Rhine, and other great rivers all flowed together across this plain, joining into a single river system that emptied into the Atlantic far beyond where their mouths are today. Doggerland was not empty wasteland. It was one of the richest landscapes in Ice Age Europe, a flat, well-watered plain teeming with wildlife. Woolly mammoths, aurochs, red deer, and wild horses grazed across its grasslands and marshlands. Rivers were full of fish. Coastal edges offered shellfish and seabirds in abundance. For the hunter-gatherer peoples of Mesolithic Europe, Doggerland was prime territory, densely inhabited, fiercely valued, and intimately known across generations. As ice sheets melted over thousands of years, sea levels rose slowly but relentlessly. The people of Doggerland retreated to higher ground, generation by generation, their homeland shrinking with each passing century. Around 6,200 BCE, a catastrophic underwater landslide off Norway, called the Storegga Slide, triggered a massive tsunami that swept across what remained of Doggerland, flooding the last low-lying areas within hours. Britain became an island. And Doggerland was gone forever. Fact 2. The Green Sahara, when the world's greatest desert was a garden. The Sahara Desert today is the largest hot desert on Earth, nearly 10 million square kilometers of sand, rock, and emptiness, a place so dry that entire years can pass without measurable rainfall in its interior. It is the defining image of barrenness, the world's most extreme expression of arid landscape. And yet, remarkably, the Sahara was not always this way. Between approximately 11,000 and 5,000 years ago, the Sahara was green, not just green at the edges, but green deep into what is now its most lifeless interior. A landscape of lakes, rivers, forests, and abundant wildlife that supported vast human populations across regions that today are completely uninhabitable. Geologists call this period the African Humid Period, or more evocatively, the Green Sahara. It was caused by a subtle but powerful shift in Earth's orbital geometry, a change in the tilt and wobble of Earth's axis known as the Milankovitch cycles, that altered the amount of solar radiation reaching the northern hemisphere during summer. This orbital shift intensified the West African monsoon, pushing rainfall deep into the Sahara interior on a scale that has no modern equivalent. The rains that today fall in the thin Sahel belt at the desert's southern edge extended hundreds of kilometers further north, reaching deep into what is now one of the driest places on Earth. The landscape that resulted was extraordinary. Lake Chad was once an enormous inland sea called Megalake Chad, covering an area larger than the modern Caspian Sea. Hundreds of rivers and streams flowed across what is now the Libyan and Algerian desert, visible today only as dry riverbeds carved into the bedrock by water that has not flowed for 5,000 years. Hippos swam in rivers in what is now the Central Sahara. Elephants, giraffes, crocodiles, and buffalo inhabited grasslands and woodlands across a region that today supports almost no large animal life. Human beings flourished across this Green Sahara. Cave paintings in the Tassili Ennager Mountains of southern Algeria depict hippos, cattle, and hunting scenes painted by people who lived in a landscape utterly unlike the desert surrounding those same mountains today. Around 5,000 years ago, as Earth's orbital configuration shifted and the monsoon retreated southward, the Green Sahara dried. The lakes shrank, the rivers died, the vegetation retreated, and the people moved south into sub-Saharan Africa, east toward the Nile Valley, where some scholars believe they contributed to the emergence of ancient Egyptian civilization. Fact 3. The Bering Land Bridge, walking from Asia to America. For most of human history, Asia and North America have been separated by the Bering Strait, a stretch of cold, shallow water approximately 85 kilometers wide at its narrowest point, separating Russia's Chukchi Peninsula from Alaska's Seward Peninsula. This narrow sea crossing is, by the standards of human migration, almost trivial. Indigenous peoples of both sides crossed it in boats for thousands of years, and modern travelers cross it by plane in under an hour. But this crossing did not always exist. For vast stretches of the Ice Age, the Bering Strait was not a strait at all. It was land, a wide, flat, windswept territory, the size of a small continent, connecting the Old World to the New in one unbroken landmass. Geologists call this territory Beringia, and at its greatest extent, during the peak of the last Ice Age around 20,000 years ago, it was not merely a narrow land bridge, but an enormous subcontinent approximately 1,000 kilometers wide from north to south, larger than the modern United Kingdom and Ireland combined. Beringia was cold, treeless, and swept by fierce winds, but it was not barren. It was a distinctive ecosystem called the Mammoth Steppe, a dry, grassy plain that was simultaneously one of the most inhospitable and one of the most productive environments of the Ice Age world, supporting enormous populations of woolly mammoths, woolly rhinoceroses, steppe bison, horses, and cave lions. It was across Beringia, most likely between 20,000 and 15,000 years ago, that the ancestors of all indigenous Americans first walked from Asia into the New World. They did not know they were discovering a new continent. They were simply following animals, moving through familiar terrain, doing what hunter-gatherers have always done. The crossing of Beringia was not a single dramatic migration, but almost certainly a complex process spanning many generations and possibly multiple waves of people moving eastward as conditions and opportunities shifted. As the Ice Age ended and sea levels rose, Beringia flooded. The Bering Strait opened between approximately 11,000 and 10,000 years ago, permanently separating the two hemispheres and cutting off the land route that had carried humanity into the Americas. The people already east of the flooding strait were sealed in the New World, the ancestors of every indigenous American civilization from the Arctic to Tierra del Fuego, stranded by rising water in a continent they would make entirely their own. Fact 4. The Inland Sea of North America, when the Midwest was ocean. Today, the American Midwest is a vast, flat landscape of farmland, rivers, and cities, landlocked, unremarkable in its geography, far from any ocean. But if you could travel back in time to approximately 100 million years ago, during the mid-Cretaceous period, and stand where Kansas City or Denver now stands, you would be standing at the bottom of a warm, shallow sea. The interior of North America was then submerged beneath a body of water that geologists call the Western Interior Seaway, an inland ocean stretching from what is now the Arctic Ocean in the north to the Gulf of Mexico in the south, splitting the continent of North America into two separate landmasses and creating one of the most biologically diverse marine environments in the entire history of life on Earth. The Western Interior Seaway existed for roughly 25 million years, from approximately 100 to 66 million years ago, disappearing, not coincidentally, around the time of the mass extinction event that ended the age of the dinosaurs. At its greatest extent, it was approximately 3,000 kilometers long from north to south, and 1,000 kilometers wide, with water depths reaching perhaps 800 meters in the center. Its waters were warm, tropical and subtropical in the south, cooler in the north, and teeming with extraordinary life. The creatures that inhabited the Western Interior Seaway were among the most spectacular marine animals that have ever existed. Mosasaurs, enormous predatory lizards related to modern monitor lizards, not to dinosaurs, reached lengths of 15 meters and were the apex predators of the seaway, pursuing fish, ammonites, and even other mosasaurs through the warm water. Plesiosaurs swam alongside long-necked elasmosaurids that could reach 14 meters in length. Giant turtles over 4 meters long moved slowly through the warm shallows. Fish the size of modern sharks, sharks larger than any living today, and enormous ammonites with coiled shells, a meter across, all shared this vanished sea. The seaway dried as the Rocky Mountains rose and changed the drainage patterns of the continent. It retreated northward and southward, becoming shallower and more restricted, until it disconnected and drained entirely around 66 million years ago. Today, its only evidence is in the fossil beds scattered across the Great Plains, the bones and shells of creatures that lived and died in a sea that once covered the American heartland, preserved in rock that was once soft seafloor mud. Fact 5. Zealandia, the sunken continent. In the southwestern Pacific Ocean, east of Australia and north of Antarctica, there lies an almost entirely submerged continent, a landmass the size of India, 94% covered by the waters of the Pacific and Tasman Sea, with only its highest peaks breaking the surface as islands. This sunken continent, recognized officially by geologists in 2017 after decades of debate, is called Zealandia, and it represents one of Earth's most dramatic examples of continental drowning, a territory that was fully above water approximately 80 million years ago and has spent the last 23 million years sinking beneath the ocean, leaving only its mountain peaks as the islands of New Zealand and New Caledonia. Zealandia was once part of the great southern supercontinent Gondwana, the ancient landmass that also gave rise to Antarctica, Australia, South America, Africa, and India. When Gondwana began breaking apart approximately 180 million years ago, the piece that would become Zealandia separated from Australia and Antarctica and drifted northward. As it drifted, the crust beneath it thinned, a common geological process when continental plates separate, and as the crust thinned, Zealandia slowly subsided, sinking below sea level over tens of millions of years until only its highest mountain ranges remained above water. What Zealandia looked like when fully above water, and what life inhabited it, we can only partially reconstruct from its visible fragments. New Zealand's extraordinary endemic wildlife, its flightless birds, its ancient tuatara reptiles, its strange and primitive plants, are remnants of a Gondwanan ecosystem that evolved in isolation for 80 million years, cut off from the rest of the world by the rising ocean. New Zealand's famous lack of native land mammals, apart from bats, is a direct consequence of its geological history. Zealandia sank before significant mammalian diversity had evolved, and the ocean barrier that formed as it submerged was too wide for most land mammals to cross. The recognition of Zealandia as a continent rather than a collection of islands is more than a semantic change. It means Earth has not 7 continents, but 8, one of which is almost entirely invisible, lying beneath thousands of meters of Pacific water, its mountains and valleys mapped by sonar rather than walked by geologists. Zealandia is a reminder that the map of Earth is not permanent, but is continuously, slowly being redrawn. Fact 6. The Amazon was once a vast inland sea. The Amazon River today is the largest river on Earth by water volume, a system so vast that it carries approximately 20% of all the freshwater that flows from land into the world's oceans. Its basin covers nearly 7 million square kilometers of tropical rainforest, a biological paradise of almost incomprehensible diversity. But the Amazon basin, as we know it, is geologically young. Tens of millions of years ago, the basin was not a river system at all, but an enormous inland sea, a body of water covering much of the continent's interior, connected to the Caribbean, and hosting marine life in the heart of what is now South America's jungle interior. The story of the Amazon's transformation begins with the rise of the Andes Mountains. Before the Andes rose to their current height, the drainage patterns of South America were entirely different from today. Rivers that now flow eastward into the Amazon, and from there into the Atlantic once flowed westward into the Pacific. As the Andes began their dramatic uplift starting approximately 25 million years ago, they blocked this westward drainage, trapping enormous quantities of water and sediment in the continental interior. A vast, shallow inland lake and swamp system developed, sometimes called the Pebas system, covering much of what is now the Amazon basin for millions of years. The Pebas system was a remarkable environment. It was brackish in places, a mixture of fresh and salt water, and supported a distinctive aquatic community that included both freshwater and marine animals mixed in unusual combinations. Giant snakes, enormous turtles, and a whale ancestor called Pebenista, discovered in Peruvian Amazonia in 2023, potentially the largest river dolphin that ever lived, adapted to the murky inland sea, all inhabited this ancient swampy interior landscape. As the Andes continued rising and the land tilted further eastward, the inland sea drained. The water found its way eastward, carving out the channel of the Amazon River as it went, eventually breaking through to the Atlantic and establishing the drainage pattern we know today. The transition occurred over millions of years, and the Amazon's extraordinary biodiversity today is partly a legacy of this dramatic geological history, the product of an ancient lake that drained, leaving behind one of the world's most complex and productive ecosystems. Fact 7. Sunderland, the lost world of Southeast Asia. In Southeast Asia, between the mainland and the islands of Indonesia, lies one of the world's most biodiverse marine regions, the shallow seas of the Sunda Shelf, teeming with coral reefs, fish, and extraordinary marine life. But look at a bathymetric map, a map that shows ocean depth, and these seas reveal themselves as something remarkable. They are extraordinarily shallow, rarely more than 120 meters deep, and their floor is unmistakably the landscape of a drowned continent. During the Ice Age, when sea levels were 120 meters lower than today, this entire shelf was dry land, a territory geologists call Sunderland, covering an area larger than India and connecting what are now the separate islands of Sumatra, Java, and Borneo to each other and to the Southeast Asian mainland. Sunderland was one of the largest and most ecologically diverse landmasses of the Ice Age world. Its landscapes range from tropical rainforest in the lowlands, continuous across what are now separate island ecosystems, to savanna and open woodland in drier regions. The great rivers of today's Sumatra, Borneo, and Java all flowed together across Sunderland into a single enormous river system. Animals moved freely across this connected landscape, which is why the same species of orangutans, tigers, elephants, and other wildlife are found on what are now separate islands. They were not separate islands when these species evolved and dispersed. The human story of Sunderland is equally profound. Our species first dispersed out of Africa approximately 70,000 years ago and moved rapidly eastward across southern Asia. The people who reached Southeast Asia during the Ice Age moved through Sunderland's lowland forests and river systems, eventually reaching the coastline of the Sunda Shelf where it dropped off into deeper water. From there, they made the first open ocean crossings in human history, reaching Australia and New Guinea when those two landmasses were still connected as a single continent called Sahel. As the Ice Age ended, the flooding of Sunderland was dramatic. Sea levels rose rapidly over thousands of years, drowning the lowland forests, fragmenting the connected landscape into islands, and compressing wildlife into the separated island ecosystems we see today. The flooding of Sunderland may be preserved in the flood myths of Southeast Asian and Pacific peoples, stories of great inundations that swept away the world, passed down in oral traditions for thousands of years after the waters rose. Fact 8. The Tethys Ocean, the sea that became mountains. Across the vast stretch of geological time, the configuration of Earth's continents and oceans has changed so dramatically that the world of 50 million years ago is almost unrecognizable compared to today. One of the most dramatic examples of this transformation is the Tethys Ocean, an ancient sea that once stretched across the entire middle belt of the ancient world, from what is now the Atlantic to what is now the Pacific, separating the northern supercontinent of Laurasia from the southern supercontinent of Gondwana. The Tethys Ocean no longer exists. It has been squeezed out of existence by the collision of continents, and in its place stand the highest mountains in the world. The Tethys Ocean reached its greatest extent approximately 150 million years ago, during the Jurassic period. It was an enormous, warm, shallow tropical sea, warmer than any modern ocean, rich in marine life and stretching unbroken for thousands of kilometers. The creatures that inhabited the Tethys included ammonites, marine reptiles, early sharks, and the ancestors of many modern marine groups. Its warm waters drove climate patterns across the ancient world, distributing heat from equatorial regions toward the poles in ways that kept Earth warmer and more uniform in temperature than it is today. The Tethys began closing as the continents drifted. Africa moved northward toward Europe, compressing the western end of the Tethys and eventually closing it entirely. The sediments that once formed the Tethys seafloor were squeezed upward to form the Alps. More dramatically, India, which had separated from Gondwana and was moving rapidly northward as a large island continent, began colliding with the southern margin of Eurasia approximately 50 million years ago. As India pushed into Eurasia, the oceanic crust of the remaining Tethys was forced downward, and the accumulated sediments of the ancient seafloor were crumpled upward, creating the Himalayas, the highest mountain range in the world. Today, the fossils of Tethys marine creatures, ammonites, marine shells, ancient fish, are found in the rocks of the Himalayas and the Tibetan Plateau, thousands of meters above sea level, carried there by the continent collision that built the mountains. The limestone of the Himalayan peaks was once seafloor sediment on the bed of the Tethys Ocean. The highest points on Earth are made of what was once the bottom of an ancient sea. Fact 9. The Great Aridification, when Asia turned to dust. Across the vast interior of the Asian continent, across the Gobi Desert, the Taklamakan, the steppes of Central Asia, the highlands of Tibet and Mongolia, there lies a landscape defined by aridity, by cold, by wind-scoured emptiness broken only by scattered oases and nomadic life. This great interior desert and steppe zone seems as if it has always been this way, ancient, unchanging, as permanent as the mountains that frame it. But it was not always this way. The aridification of Central Asia is one of the great environmental transformations of the past 50 million years, driven by the same Himalayan collision we explored in the previous fact, and its consequences shaped not just the physical landscape, but the entire trajectory of life and civilization across the Eurasian continent. Before the Himalayas reached their full height, the climate of Central Asia was dramatically different. Moisture from the Indian Ocean, carried northward by the seasonal monsoon, could penetrate far into the Asian interior, bringing rainfall to regions that today are almost completely dry. Fossil evidence from the Tibetan Plateau and Central Asian basins shows forests and grasslands in regions that today are barren desert. Animals that require abundant vegetation, including relatives of hippos and ancient tapirs, lived in landscapes that are now stone and sand. As the Himalayas rose higher, they created an increasingly effective barrier to the Indian Ocean monsoon. The mountains intercepted the moisture-laden air from the south, forcing it upward, wringing out its rainfall on the southern slopes and leaving the air dry and descending on the northern side. The higher the mountains grew, the more effectively they blocked the monsoon, and the drier the interior became. Simultaneously, the rising Tibetan Plateau altered global atmospheric circulation patterns, intensifying the cold, dry winds that sweep across Central Asia from the Arctic and northwest. The consequence was the creation of the Great Central Asian Desert and Steppe Belt, an enormous swath of arid and semi-arid land stretching from the Caspian Sea to the Pacific coast. This environmental transformation drove the evolution of the grassland-adapted wildlife that would eventually include horses, camels, and other animals central to human history. It also created the ecological conditions that would shape the nomadic cultures of the Eurasian steppe, cultures whose interactions with the settled civilizations of China, Persia, and Europe would drive some of the most transformative events in human history. Fact 10. Mega Lake Chad, Africa's vanished inland sea. In the heart of the African continent, in the flat, scorching basin where the borders of Chad, Nigeria, Niger, and Cameroon converge, there sits a lake that is disappearing before our eyes. Lake Chad today covers approximately 1,350 square kilometers, a modest body of water in a vast, flat basin, surrounded by semi-arid scrubland and home to millions of people who depend on its water and fisheries for survival. But the basin that Lake Chad sits in tells a completely different story. A story of a lake so enormous that it qualifies not as a lake, but as an inland sea, one of the largest bodies of freshwater that has ever existed on the surface of the earth. At various points in the past, most recently during the African humid period between approximately 11,000 and 5,000 years ago, the same period of the Green Sahara, Lake Chad expanded into what geologists call Mega Lake Chad. At its greatest extent, Mega Lake Chad covered approximately 1 million square kilometers, an area roughly equivalent to the modern Caspian Sea, and larger than all of the modern Great Lakes of North America combined. It was the largest lake known to have existed on Earth in the past 10,000 years, and its shorelines stretched far into what are now the deserts of Libya, Algeria, and Sudan. Mega Lake Chad was not just enormous, it was biologically extraordinary. Its warm, shallow waters supported enormous populations of fish, hippos, crocodiles, and waterbirds. Around its shores, human communities flourished, fishing and hunting, in a landscape of such abundance that population densities were among the highest on the continent. The evidence for this prehistoric human presence survives in the archaeological sites scattered across what is now the Sahara. Stone tools, pottery, fish bones, and human burials found hundreds of kilometers from any modern water source, in landscapes that are today completely lifeless. As the African humid period ended around 5,000 years ago, and the monsoon retreated southward, Mega Lake Chad began to shrink. Over millennia it contracted, leaving behind a complex of smaller lakes, wetlands, and finally the modern Lake Chad, itself only a fraction of the size it was even 50 years ago, currently shrinking due to climate change and water extraction. The empty desert basin surrounding modern Lake Chad is the exposed floor of Mega Lake Chad, a ghost landscape of ancient shorelines and abandoned beaches marking the edges of a vanished inland sea. Fact 11. The Black Sea flood, when the Mediterranean burst its banks. Today the Black Sea is a large, semi-enclosed body of water connected to the Mediterranean through the narrow straits of the Bosphorus and Dardanelles, stretching across the region between Turkey, Romania, Ukraine, Russia, and Georgia. Its surface lies only slightly below the level of the Mediterranean Sea. But approximately 7,600 years ago, the Black Sea was an entirely different kind of body of water, a large, landlocked freshwater lake sitting well below the level of the world's oceans. Isolated from the Mediterranean by a natural land barrier across what is now the Bosphorus Strait, and then, catastrophically and irreversibly, that barrier gave way. The story begins at the end of the last ice age. As the great ice sheets of the northern hemisphere melted, sea levels around the world rose dramatically, but not uniformly. The Black Sea basin enclosed by land did not rise with the global ocean. Instead, it remained a freshwater lake fed by rivers flowing in from Russia, Ukraine, and Anatolia, its surface sitting perhaps 150 meters below the level of the rising Mediterranean. Around its shores, Neolithic farming communities had established settlements, cultivating crops and herding animals in the fertile lowland landscape that surrounded the lake. Around 7,600 years ago, geologists Ryan and Pittman proposed in a landmark 1997 study, the rising Mediterranean finally breached the thin land barrier at the Bosphorus. The result was catastrophic, a roaring cascade of saltwater 10 times the volume of Niagara Falls, pouring into the Black Sea basin, raising its level by centimeters per day, and eventually submerging the surrounding lowlands under hundreds of meters of saltwater. Coastal communities were flooded permanently. The freshwater lake became a saltwater sea, and the ancient landscapes around its shores, forests, fields, settlements, were preserved beneath the anoxic, oxygen-poor deep waters that still characterize the Black Sea today, where organic materials do not decay. Whether this flood is the historical basis for the flood stories preserved across the Near East, the Epic of Gilgamesh's flood narrative, the biblical account of Noah, remains debated. The timeline roughly aligns with the earliest versions of flood myths in the region. What is certain is that the Black Sea flood was one of the most dramatic environmental transformations of the Holocene, reshaping a landscape and displacing the people who lived on it forever. Fact 12, the Zanclean flood, when the Atlantic filled the Mediterranean. If the Black Sea flood was dramatic, it was a gentle trickle compared to what happened to the Mediterranean Sea approximately 5.33 million years ago, one of the most violent flooding events in the entire history of Earth, a catastrophe so enormous that geologists have given it its own name, the Zanclean flood. The story begins 6 million years ago, when the Mediterranean was cut off from the Atlantic Ocean by tectonic movements that closed the ancient seaways connecting them. Without Atlantic water flowing in to replace what evaporated in the hot Mediterranean climate, the sea began to dry out. Over hundreds of thousands of years it shrank, becoming increasingly salty, and eventually largely evaporated, leaving behind an enormous salt desert kilometers below sea level. This period of Mediterranean desiccation is called the Messinian salinity crisis, lasting from approximately 5.96 to 5.33 million years ago. At its most extreme, the Mediterranean basin was reduced to a series of hypersaline lakes and vast salt flats, the largest desert on Earth at the time, its floor kilometers below the surrounding ocean. Rivers that had previously flowed into the Mediterranean now carved enormous canyons as they plunged toward the desiccated basin far below. The Rhône River of France carved a canyon deeper than the modern Grand Canyon. The Nile carved a gorge so deep that when geologists drill beneath the modern Nile Delta, they find ancient river sediments nearly 3 kilometers below current sea level. Then, approximately 5.33 million years ago, the Atlantic broke through. The exact mechanism, gradual erosion, an earthquake or tectonic movement, is still debated, but what followed may have been the largest flood in the history of the planet. Atlantic water poured through the opening, initially a trickle that rapidly widened as it eroded the barrier. Geologists estimate the eventual flow was millions of times greater than Niagara Falls. The Mediterranean refilled entirely, rising by perhaps 10 meters per day, in what may have been as little as a few months to a few thousand years. The Zanclean flood transformed Earth's climate, ocean circulation, and the evolution of life in the region. The isolated creatures that had evolved in the Mediterranean's hypersaline lakes were drowned or replaced by Atlantic species. The Mediterranean we know today, with its specific fish, its coral communities, its currents, was reborn in this ancient catastrophe, the legacy of a flood that may have filled an entire sea in the space of a human lifetime. Fact 13, the Mammoth Steppe, the lost grassland that fed an Ice Age world. In the ecological imagination of the Ice Age, the dominant image is of glaciers, vast, crushing ice sheets burying everything beneath kilometers of frozen water. But most of the land that would become Europe, Asia, and North America was not under ice at all. The vast majority of the Ice Age world was covered by an ecosystem that no longer exists anywhere on Earth. The Mammoth Steppe, the most extensive grassland biome in the history of our planet, stretching in an almost unbroken band from Western Europe across Siberia, across Beringia, and into North America. The Mammoth Steppe was not merely a cold, impoverished version of modern grasslands. It was an extraordinarily productive ecosystem, more like a cold Serengeti than a modern Arctic tundra. The grass species that dominated it were highly nutritious, growing rapidly during the brief but intense Ice Age summers, and then freezing into preserved form through the long winters, essentially storing their nutritional value like natural hay. This abundant forage supported populations of large herbivores at densities that would astonish a modern ecologist studying the present-day Arctic. where the thin, boggy tundra supports only a fraction of the biomass that the mammoth steppe once sustained. The cast of animals that inhabited the mammoth steppe reads like a catalogue of ecological wonder. Woolly mammoths were the keystone species, their feeding habits maintaining the grassland ecology, trampling shrubs, pushing snow aside to expose grass, and fertilizing the soil in exactly the same way that modern elephants maintain the African savanna. Woolly rhinoceroses, steppe bison, cave lions, short-faced bears, cave hyenas, and enormous deer called Irish elk all shared this vanished landscape. Horses, which would later be domesticated and transform human history, evolved on the mammoth steppe, their body forms shaped by millions of years of grazing on this rich, cold grassland. The mammoth steppe began its collapse approximately 12,000 years ago as the climate warmed. Warming temperatures transformed the frozen grassland into waterlogged tundra and boreal forest, ecosystems that could not support the enormous herds. The mammoths, rhinoceroses, and other megafauna disappeared within a few thousand years, victims of habitat loss and possibly human hunting pressure. What replaced them was the frozen, boggy, species-poor tundra of the modern Arctic, a pale ecological shadow of the vanished world it replaced. Fact 14. Pangaea before the world was split apart. If you look at a map of the modern Earth, the shapes of the continents seem to almost fit together, the bulge of West Africa fitting into the indentation of the eastern seaboard of South America, the curve of the Arctic coast of Russia paralleling that of North America. This jigsaw puzzle appearance is not coincidence. It is the memory of an ancient time when all of Earth's continents were joined into a single supercontinent, a vast, unbroken landmass that stretched from pole to pole and covered nearly a third of the Earth's surface. Geologists call this supercontinent Pangaea, from the Greek meaning all land, and it existed from approximately 335 to 175 million years ago, before breaking apart into the fragments we call continents today. Pangaea was not the first supercontinent in Earth's history. There were earlier supercontinents called Rodinia, Nuna, and others, but it is the most recent and therefore the best understood, and its breakup directly produced the world we live in. At its greatest extent, Pangaea was surrounded by a single global ocean called Panthalassa, with one smaller inland sea called the Tethys Ocean. The climate of Pangaea was extreme. Its vast interior, far from any ocean's moderating influence, experienced temperature swings that dwarfed anything in the modern world, with scorching summers and brutal winters across the central regions. Life on Pangaea was radically different from life today, yet its fossils explain patterns we see in the modern world. The same dinosaur species have been found on different continents, species that could only have shared a common geographic range if those continents were once connected. The same ancient plant called Glossopteris grew across what are now South America, Africa, Antarctica, India, and Australia, 6 separate landmasses that were once joined in the southern portion of Pangaea called Gondwana. These fossil connections were among the first pieces of evidence that convinced geologists the continents had once been united. Pangaea began breaking apart approximately 175 million years ago, first splitting into Laurasia in the north and Gondwana in the south, then fragmenting further as the Atlantic Ocean opened and continents drifted to their current positions. The process of continental drift is ongoing. The Atlantic is still widening, Australia moving northward, Africa slowly splitting along the East African Rift Valley. In about 250 million years, the continents may rearrange into a new supercontinent that some geologists call Pangaea Ultima. Fact 15. The Carboniferous forests, when trees invented wood. 350 million years ago, the Earth was covered by forests unlike anything alive today, immense, alien landscapes of giant club mosses and horsetails rising 30 meters into the air, forming dense, wet jungles across the vast tropical lowlands of what would eventually become Europe and North America. These were the Carboniferous forests, and their existence shaped the modern world in ways so fundamental that almost nothing about our civilization would be possible without them. The coal that powered the Industrial Revolution, the oil that powers the modern economy, the oxygen-rich atmosphere we breathe, all of it is a legacy of these vanished forests and the strange biological accident that allowed them to exist. The Carboniferous period, from approximately 359 to 299 million years ago, was defined by forests dominated by lycopsids, enormous relatives of the tiny club mosses that grow today as low-lying ground plants. In the Carboniferous, these lycopsids grew into trees 30 to 40 meters tall, with distinctive diamond-patterned bark visible in fossil specimens. Tree ferns, giant horsetails called calamites, and the ancestors of modern conifers also grew in these dense, wet jungles across the ancient tropical lowlands. The extraordinary fact about the Carboniferous forests is what happened when these trees died. When a carboniferous tree fell, it did not decompose, or at least, it decomposed extraordinarily slowly. Wood had recently evolved, but the bacteria and fungi capable of breaking down lignin, the tough polymer that gives wood its strength, had not yet evolved to match it. There were no organisms capable of efficiently decomposing dead wood, so when carboniferous trees fell, they accumulated, compressed over geological time into the vast seams of coal that underlie much of Europe, North America, and Asia. This inability to decompose wood had a profound atmospheric consequence. Normally, when plants die, they release their stored carbon back into the atmosphere. In the Carboniferous, this carbon was locked into coal deposits instead, slowly removing carbon dioxide from the atmosphere and releasing oxygen. Atmospheric oxygen reached perhaps 35%, compared to today's 21%. This oxygen-rich world explains the era's gigantic insects, dragonflies with 70-centimeter wingspans, millipede relatives 2 meters long, creatures that could grow so large because the very air sustained them. Fact 16, the Great Oxidation Event, when oxygen poisoned the world. The air we breathe is composed of approximately 21% oxygen, the element our cells require to extract energy from food, the gas without which almost all complex life would suffocate within minutes. Oxygen seems as fundamental a feature of our planet as the oceans or the land itself, but Earth's atmosphere was not always oxygen-rich. For the first 2 billion years of Earth's history, more than half of our planet's entire existence, the atmosphere contained almost no free oxygen at all. The world was utterly alien, breathable to no modern creature. And the event that changed this, approximately 2.4 billion years ago, was the greatest mass extinction in the history of life, caused not by an asteroid, but by a microscopic organism photosynthesizing quietly in the ancient ocean. The culprit was cyanobacteria, single-celled organisms that evolved the ability to use sunlight to split water molecules, releasing oxygen as a waste product. Cyanobacteria had existed for some time before the Great Oxidation Event, but for millions of years, their oxygen production was absorbed by chemical reactions with iron and other minerals in the ocean and atmosphere. Then, approximately 2.4 billion years ago, these chemical sinks became saturated. Oxygen began accumulating in the atmosphere for the first time in Earth's history. The consequences were catastrophic for the organisms that had dominated the planet. The anaerobic bacteria and archaea that had evolved in an oxygen-free world found oxygen to be a deadly poison. It reacted with their cellular machinery and killed them at massive scale. The Great Oxidation Event was a mass extinction that eliminated the dominant life forms of the ancient Earth and fundamentally restructured the planet's ecosystems. The anaerobic organisms that survived retreated into the oxygen-depleted refugia they still inhabit today, deep ocean sediments, the guts of animals, and other environments sealed from the toxic gas that now dominates the atmosphere. From the catastrophe came transformation. The oxygen that poisoned the ancient world made complex, energy-demanding life possible. Without abundant atmospheric oxygen, the metabolic demands of large, active animals could never be met. The Great Oxidation Event, driven by microscopic organisms doing nothing more than living and reproducing, set in motion the 2 billion-year chain of events that eventually produced forests, dinosaurs, and human beings, all of us inheritors of a catastrophe that killed almost everything that came before. Fact 17, the Snowball Earth, when the planet froze solid. Among the most extreme episodes in all of Earth's history, and Earth's history contains some extraordinary extremes, perhaps none is more difficult to conceptualize than the Snowball Earth events, periods during which the Earth may have been almost entirely frozen from pole to pole, its oceans covered by thick sea ice and its continents buried beneath glaciers for tens of millions of years at a stretch. The most severe of these events occurred between approximately 720 and 635 million years ago, during a period called the Cryogenian, and the evidence for them is preserved in ancient rocks on every continent, rocks showing clear signs of glaciation in places that were then located in tropical latitudes, where ice should have been impossible. The mechanism that drove Snowball Earth events was a runaway ice albedo feedback. Normally, Earth's climate is self-regulating. If temperatures drop and ice forms, the white ice reflects more sunlight back into space, but this is eventually counteracted by volcanic carbon dioxide building up in the atmosphere. During the Cryogenian, something disrupted this balance. The arrangement of the continents at the time, clustered near the equator, where silicate rocks weathered rapidly and absorbed carbon dioxide, may have dropped atmospheric CO2 low enough that the cooling feedback overwhelmed the warming mechanisms. Once ice began forming and spreading from the poles, the increasing reflectivity of the ice-covered surface caused further cooling, which caused more ice, a positive feedback loop that may have driven ice coverage all the way to the equator within thousands of years. The result was an Earth where the oceans were covered by ice, perhaps a kilometer thick at the poles and hundreds of meters thick, even in tropical regions, with global average temperatures around -50 degrees Celsius, colder than modern Antarctica. How did life survive? Something did, because life exists today. The most likely refugia were hydrothermal vents on the ocean floor, where volcanic heat kept small pockets of liquid water available. Volcanic carbon dioxide slowly accumulated under the ice over millions of years, until the greenhouse effect became powerful enough to melt the ice catastrophically. The thawing likely produced extreme greenhouse conditions and violent chemical weathering as the frozen world suddenly returned to life. The organisms that survived may have been shaped by their ordeal in ways that set the stage for the explosion of complex multicellular life that followed. Fact 18. The forests of Antarctica when the frozen continent was green. Antarctica today is the coldest, driest, and most inhospitable continent on Earth, a vast ice sheet averaging 2,300 meters in thickness, where temperatures can drop below -80 degrees Celsius and almost nothing lives except hardy microorganisms and penguins on the coasts. It seems impossible that Antarctica could ever have been anything else. Yet it was. Antarctica has been warm. Antarctica has had forests. Antarctica has hosted ecosystems of extraordinary richness and diversity, and the fossil evidence of those lost worlds still lies beneath the ice, waiting in the rock for the rare geologist who chips through to find it. For most of its history as an identifiable landmass, Antarctica was not at the South Pole and was not covered in ice. It was part of the supercontinent Gondwana, located at more temperate latitudes and hosting ecosystems that tracked the climate changes of the ancient Earth. During the Permian and Triassic periods, Antarctica supported lush forests of the ancient tree Glossopteris and later of conifers and other plants. Dinosaur fossils have been found in Antarctic rocks, land-dwelling dinosaurs that clearly inhabited a landscape with vegetation, rivers, and seasons. These Antarctic dinosaurs lived in an environment that experienced months of polar darkness, suggesting they had behavioral or physiological adaptations we can only speculate about. Even as recently as 34 million years ago, Antarctica supported forests at high latitudes. Fossil pollen and leaves recovered from Antarctic sediments show beech trees and ferns growing in what was still a temperate climate, a world more like modern Patagonia than modern Antarctica. The continent had drifted to its polar position by this time, but the global climate was warm enough that ice had not yet formed. Then, approximately 34 million years ago, global temperatures dropped, the result of falling carbon dioxide levels and the opening of the Drake Passage between Antarctica and South America, which allowed the circumpolar current to isolate Antarctica thermally from warmer waters. Ice began forming, and it never fully retreated. The forests of Antarctica vanished under ice that is still there today, but they left their traces: fossil wood in rocks exposed on the Antarctic Peninsula, fossil leaves in sediment cores drilled from the seafloor, chemical signatures in ancient ice that preserve the memory of a warmer world. Antarctica was once alive. In a warming future, it may slowly, in some small measure, begin to be alive again. Fact 19. The lost rivers of the Sahara, waterways beneath the sand. Beneath the sand and rock of the Sahara Desert, largely invisible to surface observation, but increasingly mapped by satellite radar and geological survey, there lies a ghost landscape of ancient rivers, lakes, and drainage systems. A vast network of waterways that flowed across what is now the world's largest hot desert during the Green Sahara period and earlier humid periods. These lost rivers are not merely geological curiosities. They are transformative evidence of how dramatically Earth's surface can change, and their discovery is reshaping our understanding of how human populations moved across Africa during the critical periods of our species' prehistory. The most significant of the Sahara's lost rivers have been identified using imaging radar aboard satellites, which can penetrate through dry sand to reveal the bedrock topography beneath, essentially mapping the landscape as it existed before the desert formed. These radar surveys have revealed enormous ancient river valleys across Libya, Egypt, Sudan, and the wider Sahara, some of them comparable in scale to the modern Nile or Niger. In some areas, ancient rivers are traceable for hundreds of kilometers, their courses cutting through rock that has not seen flowing water for thousands of years. One of the most remarkable discoveries is the Wadi Hawar system in Sudan, an ancient river that once flowed north from the mountains of central Sudan across what is now the Eastern Sahara, eventually connecting to the Nile. During the Green Sahara period, the Wadi Hawar was a major river system supporting forests and grasslands along its banks and enabling human populations to move across regions that are now completely uninhabitable. Archaeological sites discovered along its ancient course document human presence in the deep Sahara, with stone tools, pottery, animal bones, and burials found far from any modern water source. The discovery of these lost river systems has profound implications for understanding human migration out of Africa. The conventional view of the Sahara as a permanent barrier to human movement, a vast desert that isolated sub-Saharan Africa from North Africa and the Mediterranean for most of human prehistory, is being revised. During humid periods, the Sahara's lost rivers created biological corridors across the continent, enabling the movement of people and animals across what is today an impassable barrier. The ancestors of modern human populations outside Africa may have used these vanished waterways as their highways to the world. Fact 20. The Permian mass extinction, when life almost ended. Of the 5 great mass extinctions in Earth's history, the catastrophic events that fundamentally restructured life on our planet, the most severe was not the one that killed the dinosaurs. The most severe was the Permian-Triassic extinction event, approximately 252 million years ago, sometimes called the Great Dying. In what appears to have been a geological instant, perhaps as little as 60,000 years, approximately 96% of all marine species and 70% of all land vertebrate species vanished from the fossil record. Life on Earth came closer to complete extinction at the end of the Permian than at any other point in the history of complex animals, and the ecological recovery took tens of millions of years. The cause was almost certainly a massive episode of volcanic activity in what is now Siberia, the eruption of the Siberian Traps, one of the largest volcanic events in Earth's history, which produced enormous quantities of lava, covering an area larger than the continental United States over perhaps 1 million years. But it was not the lava itself that caused the extinction. It was what the eruptions released into the atmosphere, vast quantities of carbon dioxide, sulfur dioxide, and other gases that dramatically altered the Earth's climate and ocean chemistry. The sequence of catastrophes that followed reads like a checklist of environmental nightmares. Global temperatures rose by 8 to 10 degrees Celsius within geologically short timescales. Ocean temperatures rose so dramatically that the oceans became stratified, with warm, oxygen-depleted water spreading across the seafloor and creating vast dead zones. The chemistry of the ocean changed as it absorbed carbon dioxide, becoming more acidic and dissolving the calcium carbonate shells of marine animals. The combination of warming, ocean anoxia, and acidification was lethal for marine life on a scale never seen before or since. On land, the Great Dying eliminated most of the mammal-like reptiles called therapsids that had dominated terrestrial ecosystems, clearing the way for the rise of archosaurs, the group that would eventually give rise to the dinosaurs. The world that emerged from the Permian extinction was radically different, its ecosystems simplified, its diversity depleted, its trajectory permanently altered. The Great Dying was the closest life has come to losing the complex multicellular experiment entirely, and the fact that it survived at all is perhaps the most remarkable aspect of the story. Fact 21. The Chicxulub impact, the day the sky fell. 66 million years ago, on an ordinary day in the late Cretaceous period, a chunk of rock approximately 10 to 15 kilometers wide struck the Earth at a point in what is now the Yucatan Peninsula of Mexico, traveling at roughly 20 kilometers per second. The impact lasted perhaps a second. Its consequences lasted millions of years. The Chicxulub impactor struck with an energy 1 billion times greater than the atomic bomb dropped on Hiroshima, vaporizing itself and surrounding rock instantaneously, triggering a chain of catastrophes that would end the reign of the non-avian dinosaurs and reset the evolutionary trajectory of life on Earth. The immediate effects were incomprehensible in scale. The explosion generated a fireball visible from half a continent away. A tsunami potentially hundreds of meters tall radiated outward across the Gulf of Mexico. The vaporized rock and superheated debris thrown into the upper atmosphere rained back down as molten droplets across the entire planet, briefly heating the atmosphere so intensely that the surface temperature worldwide may have risen high enough to ignite wildfires across every continent simultaneously. Land animals that survived the initial impact may have had no more than hours before conditions became unsurvivable across vast regions. The short-term catastrophe was only the beginning. Vast quantities of sulfur released from the vaporized impact site formed aerosols in the upper atmosphere, blocking sunlight and triggering a period of rapid global cooling, an impact winter lasting years to decades. Photosynthesis collapsed worldwide. The food chains that depended on plants unraveled from the bottom up. In the oceans, the extinction of photosynthesizing plankton triggered cascading collapses throughout marine ecosystems. In total, approximately 75% of all species on Earth went extinct. Yet the Chicxulub impact was also, in a profound sense, the event that made us possible. The extinction of the non-avian dinosaurs, dominant for 165 million years, vacated the ecological niches that small, marginal mammals then expanded to fill. Within 10 million years, mammals had diversified explosively into the roles previously held by dinosaurs. The lineage that would eventually produce primates, and ultimately humans, was among the survivors, small nocturnal insectivores that happened to be in exactly the right body plan to endure what the dinosaurs could not. Fact 22. The Great Barrier Reef's ancient ancestors, reefs that vanished. The Great Barrier Reef of Australia is the largest living structure on Earth, a vast complex of coral reefs stretching over 2,300 kilometers along the Queensland coast, visible from space, home to an extraordinary diversity of marine life. It is also, by geological standards, extraordinarily young. The current Great Barrier Reef began forming approximately 20,000 years ago, as sea levels rose at the end of the last ice age and flooded the shallow continental shelf off northeastern Australia. But there have been other Great Barrier Reefs before this one, reefs that flourished, declined, and vanished as sea levels fell and rose through the cycles of the Ice Age, leaving their ancient skeletons buried beneath the modern reef and the surrounding seafloor. Coral reefs are among the most productive and biodiverse ecosystems on Earth, but also among the most geologically sensitive. They can only grow in shallow, warm, clear water, typically less than 30 meters deep, with temperatures between about 18 and 30 degrees Celsius. When sea levels fall during ice ages, reefs are exposed to air and die. When sea levels rise too rapidly, the water can become too deep too quickly for corals to grow upward fast enough to stay within the light zone. Reef ecosystems have been repeatedly constructed and destroyed through geological time, each new reef building on the foundations of its predecessors. The fossil reef systems underlying the modern Great Barrier Reef record at least 5 major reef-building episodes over the past 600,000 years, each corresponding to an interglacial period when sea levels rose and conditions were suitable for reef growth. Between these episodes, as ice ages lowered sea levels, the reefs died back, their carbonate skeletons exposed to erosion and dissolution. The modern reef is the 6th and most recent, built on a foundation of its own ancestral ruins. This geological history carries a sobering contemporary message. The current Great Barrier Reef is under severe stress from rising ocean temperatures, ocean acidification, and other human-caused environmental changes. Mass bleaching events, caused by elevated water temperatures, have killed large portions of the reef in recent years. If conditions exceed the reef's tolerance for long enough, the current reef system will join its predecessors as a fossil record of a vanished world, waiting beneath whatever ecosystem replaces it. Fact 23. The Younger Dryas, when the world snapped back to ice. At the end of the last ice age, the world did not warm gradually and smoothly into the temperate climate we know today. Instead, it experienced one of the most abrupt climate reversals in the geological record, a sudden return to near-glacial conditions lasting approximately 1,200 years, beginning around 12,900 years ago and ending around 11,700 years ago. Climatologists call this episode the Younger Dryas, named after a small Arctic wildflower called Dryas octopetala, whose pollen appears abundantly in sediment records from this cold period. The Younger Dryas is one of the best-studied abrupt climate events in Earth's history, and its causes illuminate the extraordinary fragility of the climate system that supports modern civilization. The warming at the end of the last ice age had been proceeding for thousands of years before the Younger Dryas began. Temperatures had risen substantially. The great ice sheets of North America and Europe were melting. Sea levels were rising. Ecosystems were responding, forests advancing northward, grasslands transforming, animal communities reorganizing. For the people of the time, late Paleolithic and early Mesolithic hunter-gatherers across Europe, Asia, and the Americas, the world was warming, opening up. And then, within decades, possibly within years, it stopped. The most widely accepted mechanism for the Younger Dryas is the disruption of the Atlantic meridional overturning circulation, the system of ocean currents that transports warm water from the tropics northward into the North Atlantic, releasing heat that keeps northwestern Europe dramatically warmer than its latitude would otherwise suggest. As the Great North American ice sheet melted, it released enormous quantities of cold freshwater into the North Atlantic, possibly through the sudden draining of a vast glacial lake called Lake Agassiz. This influx of cold freshwater disrupted the density-driven sinking of North Atlantic water that drives the circulation, effectively shutting down the ocean heat pump. The Younger Dryas ended just as abruptly as it began, Ice cores from Greenland show that temperatures in the region rose by perhaps 10 degrees Celsius within a decade or two, one of the fastest natural climate changes ever recorded. The end of the Younger Dryas marks the beginning of the Holocene, the current geological epoch, and the relatively stable, warm climate of the Holocene provided the foundation for agriculture and civilization. We live, in a sense, in the calm after the Younger Dryas storm. Fact 24. The lost megafauna of Australia, continent of vanished giants. When the first modern humans arrived on the continent of Australia approximately 50,000 years ago, they entered a world of animals unlike anything their ancestors had encountered in Africa or Asia, a continent of evolutionary isolation that had produced its own extraordinary fauna over tens of millions of years. And many of the most spectacular creatures of this ancient Australian fauna were giants, animals that dwarfed their modern relatives and represented evolutionary experiments found nowhere else on Earth. Within approximately 10,000 to 20,000 years of human arrival, most of these Australian giants were gone, their disappearance one of the most debated and consequential extinction events in the history of our species. The giants of ancient Australia were extraordinary. Diprotodon optatum, sometimes called the giant wombat, though it was more accurately a relative of wombats and koalas, was the largest marsupial that ever lived, the size of a modern hippopotamus, weighing up to 2,700 kilograms and browsing on shrubs and grasses across the continent. Procoptodon goliath was an enormous short-faced kangaroo 3 meters tall, with hands adapted for pulling down tree branches rather than knuckle walking. Thylacoleo carnifex, the marsupial lion, was a powerful predator with a bite force proportionally greater than any living cat, its teeth adapted for puncturing and slicing. The cause of the Australian megafauna extinctions remains genuinely contested. The two primary candidates are human hunting, the ovicle hypothesis, which proposes that the megafauna were naive to human hunters and were driven to extinction relatively quickly after human arrival, and climate change, particularly the increasing aridity that characterized Australia during the last glacial period. The current scholarly consensus leans toward a combination of both factors, with human hunting delivering the fatal blow to populations already stressed by climatic change. What is not debated is the ecological consequence. The loss of the Australian megafauna fundamentally transformed the continent's ecosystems. Large herbivores like Diprotodon had shaped vegetation through their feeding and movement in ways that maintained specific plant communities. Without them, vegetation changed, fire regimes shifted, and the ecological structure of the continent was permanently altered. The Australia that European settlers encountered in the 18th century was already a profoundly simplified version of the continent's former biological richness. Fact 25. The North American ice sheet, a kilometer of ice over Chicago. During the last ice age, at its glacial maximum approximately 20,000 years ago, much of North America north of a line roughly following the modern Ohio and Missouri rivers was buried beneath one of the largest ice sheets in Earth's recent history. The Laurentide ice sheet covered approximately 13 million square kilometers, an area larger than the modern Antarctic ice sheet. Over what is now Chicago, the ice was perhaps 2 to 3 kilometers thick. Over Hudson Bay and the heart of the ice sheet, it may have been 4 kilometers thick, a mass of ice so enormous that its weight depressed the underlying bedrock by hundreds of meters, a depression that is still slowly rebounding today, thousands of years after the ice melted. The Laurentide ice sheet was not static. Its edges advanced and retreated in response to climate fluctuations, and as it moved, it reshaped the landscape with a thoroughness that makes it perhaps the most powerful geological force in North American prehistory. Glaciers carry rock embedded in their base and sides, ranging from fine clay to enormous boulders, and as they move, they grind the bedrock beneath them, scour valleys, polish rock surfaces smooth, and deposit their carried material in characteristic landforms when they finally melt. Virtually every landscape feature of the northern United States and Canada north of the glacial limit reflects the action of the Laurentide ice sheet. The Great Lakes, Superior, Michigan, Huron, Erie, and Ontario are the most dramatic legacy of the ice sheet. They occupy basins scoured by glacier movement along pre-existing geological weaknesses, then filled with meltwater as the ice retreated. The flat topography of the Midwestern United States and Canadian prairies reflects the enormous quantities of glacial sediment deposited as the ice melted. Thousands of lakes in Minnesota, Ontario, and Manitoba were created by the ice sheet's action. The Hudson River Valley and the Finger Lakes of New York all bear the direct imprint of glacial erosion. The melting of the Laurentide ice sheet was one of the defining events of the past 20,000 years. Enormous quantities of meltwater flooded southward and eastward, creating vast temporary lakes along the glacier's margins, including the enormous Lake Agassiz, which at its greatest extent covered more area than all of the modern Great Lakes combined. The final melting of the ice, completed by approximately 6,000 years ago, raised global sea levels by dozens of meters and transformed the geography, hydrology, and ecology of an entire continent. Fact 26: The Lost Forests of Easter Island, an ecocide written in pollen. Easter Island, Rapa Nui, is famous worldwide for its moai, the enormous stone statues that stand along its coastlines, staring inland with their backs to the sea. But the environmental story of Rapa Nui, the complete deforestation of an island once covered in dense forest, is one of the most thoroughly documented examples of human-caused ecological collapse in recorded history, preserved in extraordinary detail in the sediment cores drilled from the island's crater lakes and studied by scientists over many decades. When Polynesian settlers first arrived on Rapa Nui, most likely between 800 and 1200 CE, they found a forested island. Pollen records from the sediment cores show that before human arrival, the island was covered by a forest dominated by a now extinct species of giant palm, Pachylococos disperta, along with Toromiro trees and other native vegetation. The giant palm produced large nuts that were an important food source. Its root systems held the island's thin volcanic soil in place, and its canopy retained moisture and moderated the climate against the relentless Pacific wind. This was not a marginal scrubland, but a productive, sheltered forest ecosystem on which the entire island ecology depended. Over the following centuries, the pollen record tells an unambiguous story of progressive deforestation. The palm pollen declined steadily, replaced by the pollen of grasses and weeds that colonized disturbed ground. Deforestation accelerated as the island's population grew, requiring more land for agriculture, more wood for constructing and transporting the moai, more fuel for cooking and cremation, and more timber for the boats on which islanders depended for deep-sea fishing. By approximately 1500 CE, the giant palm was extinct on the island. By the time of European contact in 1722, the island was almost completely treeless. The consequences for Rapa Nui's human population were severe. Without forest cover, the island's thin soils eroded rapidly. Agricultural productivity declined as soil quality deteriorated. The loss of timber made it impossible to build the ocean-going canoes needed for deep-water fishing. The island's food system progressively collapsed, contributing to a population decline that preceded and then accelerated after European contact. Rapa Nui is often cited as a parable of ecological overexploitation, a civilization that consumed the natural foundations of its own existence. Fact 27: The tundra that was prairie, how the Ice Age ended in North America. Today, the landscape of the far north of North America, the vast territories of northern Canada and Alaska stretching to the Arctic coast, is tundra, frozen, waterlogged, treeless, covered in low shrubs and mosses, with permafrost lying just below the surface. It is a landscape of ecological simplicity compared to the grasslands of the temperate zones to the south. But during the Ice Age, as we explored in our discussion of the mammoth steppe, much of this landscape was an entirely different thing, a productive, dry grassland that supported enormous populations of large animals. The transformation of the mammoth steppe into modern Arctic tundra was one of the most profound ecological changes of the past 15,000 years. The key difference between the mammoth steppe and the modern tundra is not simply temperature, it is moisture. The Ice Age was paradoxically drier than the modern world in much of the Arctic. Cold air holds less moisture than warm air, and the prevailing winds carried relatively little precipitation into the interior of the northern continents. This dryness kept the soil frozen but not waterlogged, allowing grasses and herbaceous plants to grow in dense, productive mats during the brief Arctic summers. The dry soil also meant that solar energy was used to heat the surface rather than evaporate water, giving plants an intense but short growing season. As the Ice Age ended and temperatures rose, the atmosphere could hold more moisture. Precipitation increased. The previously dry Arctic soil became waterlogged, and waterlogged soil creates very different conditions for plant growth. It favors mosses, sedges, and shrubs over the nutritious grasses that had supported the megafauna. The waterlogged soil also encourages permafrost at deeper levels, as water in the soil freezes and creates an impermeable layer that prevents drainage, making the soil even wetter in a self-reinforcing cycle. The mammoths and other steppe megafauna could not adapt to this transformed landscape. Their digestive systems were adapted for the high-quality grasses of the steppe, not the low nutritional mosses and sedges of the tundra. Their enormous bodies required vast quantities of high-quality forage that the transformed landscape could no longer provide. The ecological world they had inhabited for hundreds of thousands of years dissolved beneath their feet as the climate warmed, and they vanished with it, leaving behind only bones in the permafrost and the ghost of a landscape that existed only in Ice Age memory. Fact 28. The Mediterranean's ancient forests, trees that built civilizations. The Mediterranean basin today is a landscape of scrubby hillsides, rocky outcrops, and thin soils baking under an intense summer sun, a beautiful but ecologically simplified landscape that bears little resemblance to its ancient condition. 2,000 years ago, the hills of Greece, Italy, Lebanon, and North Africa supported dense forests, cedar forests in Lebanon that grew to enormous heights, oak and pine forests in Greece that covered mountains now bare, forests in North Africa that provided timber for Carthaginian and Roman fleets. These forests are gone, consumed by the civilizations that rose in the Mediterranean basin. Their disappearance, one of the best documented examples of how human civilization can permanently transform a landscape. The evidence for the ancient Mediterranean forests comes from multiple sources. Ancient texts are remarkably explicit. Homer describes forests on Greek islands that are now rocky and bare. Plato, writing in the 4th century BCE, noted that the hills of Attica had been stripped of topsoil through deforestation and erosion, comparing the remaining landscape to the skeleton of a body stripped of flesh. Pollen records from lake sediments throughout the Mediterranean document the progressive decline of forest pollen and its replacement by cereal pollen and weed species as agriculture expanded and forests were cleared. The cedars of Lebanon are perhaps the most famous casualty of Mediterranean deforestation. The cedar forests were among the most magnificent in the ancient world, cedars growing to 40 meters tall, producing the finest timber in the ancient Near East. Egyptian pharaohs sent expeditions to Lebanon to acquire cedar for temple construction. Solomon's temple in Jerusalem was built of Lebanese cedar. The Phoenician maritime empire was built on Lebanese cedar. Harvested so extensively that by the Roman period they were already severely depleted, today only about 12 remnant groves survive, a tiny fraction of the vast forests that once blanketed those mountain slopes. Without forest cover, the thin Mediterranean soils eroded rapidly, washing down bare hillsides into the sea during winter rains, taking with them centuries of accumulated fertility. The loss of topsoil made reforestation increasingly difficult, trapping degraded landscapes in a cycle of erosion and bare rock that persists today. The rocky hillsides of Greece and other Mediterranean countries are not natural landscapes. They are the legacy of millennia of human land use, permanent records of a vanished forest world. Fact 29. The Aral Sea, the fastest disappearing lake in modern history. In Central Asia, between the modern countries of Kazakhstan and Uzbekistan, there was once a vast body of water, the Aral Sea, the 4th largest lake in the world, covering approximately 68,000 square kilometers, a shallow but biologically rich inland sea that supported thriving fishing industries, moderated the local climate, and sustained human communities around its shores for thousands of years. Today, the Aral Sea has almost entirely disappeared. In less than 60 years, through Soviet-era irrigation projects and subsequent mismanagement, one of the world's Great Lakes has been reduced to a series of disconnected, hypersaline remnants covering less than 10% of its original area, the fastest and most complete destruction of a major body of water in recorded history. The Aral Sea was fed by 2 major rivers, the Amudarya and Sirdarya, flowing from the mountains of Tajikistan and Kyrgyzstan across the Central Asian plains. For thousands of years, the rivers delivered enough water to maintain the lake's level against losses to evaporation. Then in the 1960s, the Soviet Union implemented an ambitious plan to transform the arid plains of Central Asia into a cotton-producing region by diverting the waters of both rivers into a vast irrigation network. The plan worked for cotton. The Soviet Union became a major cotton exporter. The consequence for the Aral Sea was catastrophic. With its river inflows diverted, the Aral Sea began shrinking. By the 1980s, the decline was dramatic and visible from space. The fishing industry, which had produced 40,000 tons of fish per year in the 1950s, collapsed entirely as the lake became too salty for fish to survive. The fishing fleet was stranded on the former lakebed, rusting hulks sitting on dry sand, kilometers from any water, in one of the most iconic and heartbreaking images of ecological catastrophe in the modern world. The human consequences have been severe. Communities that once lived on the lake's shores now experience a harsh continental climate without the lake's moderating influence. Blowing salt and pesticide residues from the exposed lakebed create serious public health crises across the region. The fishing industry that once sustained thousands of families is gone. The Aral Sea is not a distant geological event. It is a warning delivered within living human memory, a demonstration of how quickly and irreversibly a great body of water can be removed from the earth. Fact 30. The lost canopy of the Congo, Africa's ancient forest. The Congo Basin of Central Africa is home to the second largest tropical rainforest on Earth, approximately 1.7 million square kilometers of dense, layered forest, harboring extraordinary biodiversity including gorillas, bonobos, forest elephants, and hundreds of thousands of plant, insect, and animal species. It appears ancient, permanent, primordial, but the Congo forest has not always been what it is today. It has contracted and expanded dramatically in response to climate changes over the past 100,000 years, and its history reveals that even the world's greatest forests are dynamic, fragile, and capable of being dramatically reduced in geological eye blinks. During the last glacial maximum, approximately 20,000 years ago, the Congo Basin forest contracted significantly. Cooler, drier conditions reduced rainfall across Central Africa, causing large portions of the forest to shrink into isolated refugia, islands of forest surrounded by grassland and dry woodland. Genetic studies of the Congo forest's wildlife support this history. Many forest-dependent species show patterns of genetic diversity consistent with populations that were severely reduced during the cold, dry periods of the Ice Age, then expanded as the forest regrew in warmer, wetter conditions. More recently, palynological evidence, the study of ancient pollen from lake sediments, reveals that the Congo forest experienced a dramatic and mysterious contraction approximately 2,500 years ago, during what should have been climatically favorable conditions. Pollen records from lakes throughout the Congo Basin show a sudden expansion of grassland and savanna species at this time, suggesting a large portion of the forest was replaced by open vegetation for several centuries. The cause is debated, a specific drought event, human land clearing, or both acting together. What is remarkable is that a forest of this scale could contract so rapidly under conditions that were not obviously extreme. The Congo forest today faces unprecedented pressure from human activity, deforestation for agriculture, logging for timber, and road networks opening previously inaccessible forests to exploitation. The forest's history shows it has survived Ice Age contractions and mysterious ancient droughts. But the current rate of human-caused deforestation is faster than any natural change in the forest's recorded history, and the ecological consequences would be felt not just locally, but across the global climate system the forest helps regulate. Fact 31. The passenger pigeon, when billions became none. In the early 19th century, the passenger pigeon was the most numerous bird species in North America, and possibly the most numerous bird species that has ever existed on Earth. Estimates of the population at its peak range from 3 billion to 5 billion individual birds, representing somewhere between 25 and 40% of all the birds in North America. Flocks were so enormous that they darkened the sky for days as they passed overhead, their wing beats audible as a roar from kilometers away, their droppings falling like rain, their weight breaking branches of the trees in which they roosted. And then, within less than a century, every last one of them was gone, the largest and most rapid extinction of a numerous species in recorded human history. The passenger pigeon was not a rare, marginal creature clinging to survival in isolated habitats. It was the dominant bird of the eastern North American deciduous forest, a keystone species whose migrations fertilized vast areas of forest floor, whose enormous roosting colonies created complex disturbances that other species depended on, and whose presence was woven so deeply into the ecology of the eastern woodlands that the forest itself was shaped by their passing. They fed primarily on mast, the nuts and acorns of forest trees, and moved in massive nomadic flocks that followed the mast production across the continent. The destruction of the passenger pigeon was accomplished by two forces in combination: the wholesale clearing of the eastern North American forests and commercial hunting of a scale that is almost incomprehensible to modern minds. Professional hunters followed the flocks, slaughtering birds at their roosting sites by the millions, shooting them, netting them, smoking them from their roosts, killing them with poles. The birds were so tightly packed in their roosts that hundreds could be killed with a single shot. The bodies were salted and shipped to eastern cities by the trainload, sold as cheap protein for the rapidly growing urban populations of the industrializing United States. The last wild passenger pigeon was recorded in 1900. The last living individual, a captive female named Martha, held at the Cincinnati Zoo, died on September 1, 1914. The species that had once numbered in the billions was gone, completely and permanently, in less than a human lifetime. Martha's body was frozen in a block of ice and sent to the Smithsonian Institution, where it remains today, the physical remnant of a world that can never be recovered. Fact 32. The Great Auk, the penguin of the north that never was. The Great Auk was not a penguin, but to a modern eye it looked remarkably like one, a large, flightless seabird of the North Atlantic, standing approximately 75 to 85 centimeters tall, with black upperparts and white underparts, a large hooked bill, and the upright posture of a bird that had traded wings for exceptional diving ability. It was entirely unrelated to penguins. The resemblance was the product of convergent evolution, two separate lineages independently arriving at similar body plans through similar ecological pressures. The Great Auk evolved in the cold, fish-rich waters of the North Atlantic, and for millions of years it thrived there, nesting in enormous colonies on rocky islands from Canada to Iceland to the British Isles. Then human beings discovered it, and within a few centuries it was gone. The Great Auk was an exceptional swimmer. Its wings, though useless for flight, served as powerful flippers that drove it through the water at speeds comparable to modern penguins. It fed primarily on fish, diving to considerable depths to pursue its prey. On land it was clumsy and slow, waddling upright on its short legs, entirely defenseless against predators, a quality that made it extraordinarily vulnerable to human hunting. It nested in dense colonies on a small number of rocky, inaccessible islands, laying a single egg per year on bare rock. Its entire reproductive effort concentrated in these few specific locations. It had no evolutionary experience of the kind of systematic, unlimited predation that human hunters could deliver. For centuries, sailors and fishermen had harvested great auks from their nesting colonies, using them for food, for fish bait, and for their downy feathers, which were highly valued for stuffing mattresses and pillows. The birds were so tame and so unable to flee on land that sailors could simply drive them up planks and into boats. By the late 18th century, the population had been dramatically reduced. By the early 19th century, the Great Auk survived only in one final stronghold, a rocky stack called Eldey, off the coast of Iceland. The last confirmed pair of Great Auks was killed on Eldey on June 3, 1844, by 3 Icelandic fishermen working for a collector who wanted museum specimens. The female was incubating an egg. The fishermen strangled the 2 adults and crushed the egg with a boot. The species ceased to exist, killed not by catastrophe, but by 3 men on a rocky island on a summer afternoon. Fact 33. The woolly mammoth, the giant that lived until yesterday. In the popular imagination, the woolly mammoth is an ancient creature, a shaggy, tusked beast of the deep ice age, as remote from our world as the dinosaurs. But this perception is dramatically wrong. The woolly mammoth survived the end of the last ice age, retreating to isolated refugia as the world warmed and its habitat shrank. The last populations of woolly mammoths on Earth, small herds living on Wrangel Island in the Arctic Ocean, north of Siberia, survived until approximately 4,000 years ago, well into the period of written human history, long after the first cities had risen in Mesopotamia and the first dynasties had ruled in Egypt. The mammoth was not a creature of the ancient past, it was our contemporary. The story of the woolly mammoth's survival on Wrangel Island is one of the most remarkable episodes in the recent history of life on Earth. As the Great Mammoth Steppe ecosystem collapsed across the Eurasian and North American mainland, driven by climate change and human hunting pressure, mammoths disappeared from the continental landmasses. But Wrangel Island, a large Arctic island cut off from the mainland by rising seas at the end of the Ice Age, preserved a small, isolated population in a kind of ecological time capsule for thousands of years after their mainland relatives had vanished. The Wrangel Island mammoths were not the robust giants of the Ice Age steppe. Isolated on an island with limited food resources, they gradually evolved into a smaller form, still recognizably woolly mammoths, but somewhat smaller than their mainland ancestors. Genetic studies of their remains show evidence of reduced genetic diversity, accumulation of harmful mutations, and signs of inbreeding. When the Wrangel Island mammoths finally went extinct around 4,000 years ago, the cause was likely a combination of accumulated genetic burden and the possible arrival of human hunters. The woolly mammoth's recent demise has made it a prime candidate for de-extinction, using ancient DNA and modern genetic engineering to reconstruct something resembling a mammoth. Several scientific teams are working toward this goal using CRISPR gene editing technology to introduce mammoth genes into elephant cell lines. Whether true woolly mammoth can or should be recreated is the subject of intense scientific and ethical debate. What is not debated is that the mammoth's world, the mammoth steppe, no longer exists, and any recreated mammoth would face a landscape utterly unlike the one its species evolved to inhabit. Fact 34. The Cretaceous chalk seas, when England was tropical ocean. Across southern England, northern France, Denmark, and other parts of northwestern Europe, there stretches a distinctive geological formation, thick deposits of white chalk that form the famous White Cliffs of Dover, the chalk downs of southern England, and similar landscapes across the region. This chalk, soft and white and crumbling, is one of the most familiar rock types in the landscape of northwestern Europe. But chalk is not just rock. It is the accumulated remains of billions upon billions of microscopic marine organisms, the fossilized skeletons of tiny algae called coccolithophores, that lived and died in a warm, shallow, tropical sea that covered what is now England, France, and much of northwestern Europe approximately 100 to 66 million years ago. The sea that produced the chalk deposits of Europe is sometimes called the Cretaceous Chalk Sea, and it was one of the most distinctive marine environments of the Mesozoic era. During the late Cretaceous period, global sea levels were dramatically higher than today, perhaps 100 to 200 meters higher, enough to flood vast areas of low-lying continental interior and create extensive shallow seas across what are now dry land. The European continent was largely submerged, reduced to a scattering of tropical islands rising above the warm, clear waters of this inland sea. The water was warm, clear, and rich in the microscopic algae that were slowly, over millions of years, accumulating on the seafloor. The depth of chalk deposited during this period is remarkable. In some places, it reaches 300 to 500 meters in thickness, representing an almost inconceivable quantity of biological material accumulated over tens of millions of years. Each meter of chalk represents approximately 100,000 years of biological accumulation. The White Cliffs of Dover, at their highest point roughly 110 meters tall, represent approximately 11 million years of geological history, preserved in the accumulated remains of organisms too small to see with the naked eye. The creatures that inhabited the chalk sea alongside the coccolithophores were extraordinary. Mosasaurs and plesiosaurs swam through what is now the English countryside. Ammonites with elaborate spiral shells coiled through the warm water. Large sharks, giant fish, and sea turtles all lived in this vanished tropical sea. When the Cretaceous ended and the sea retreated, the accumulated chalk was slowly uplifted and exposed by geological processes, forming the landscape of modern southern England, a landscape built entirely from the remains of a tropical sea gone 66 million years ago. Fact 35. The Lost Prairie, North America's ocean of grass. Before European settlement, the interior of North America was covered by one of the largest and most ecologically extraordinary grassland ecosystems on Earth, the Great Plains grassland, stretching from the Gulf of Mexico to the boreal forests of Canada, from the Rocky Mountains to the Mississippi River and beyond. This was not merely an expanse of grass. It was an ecosystem of extraordinary biological complexity, shaped over millions of years by the interactions of grasses, fire, drought, and the most spectacular assemblage of large herbivores that has inhabited North America since the Ice Age, dominated above all by the American bison, which ranged across the plains in herds that may have numbered 30 to 60 million animals. The tallgrass prairie, which occupied the eastern portion of the plains where rainfall was higher, was among the most biodiverse temperate grassland ecosystems on Earth. Its grasses, big bluestem, little bluestem, Indian grass, switchgrass, grew 6 feet tall or more, their roots penetrating 2 to 3 meters into the deep, rich soils they had created over thousands of years of growth, death, and decomposition. The deep root systems of prairie grasses are responsible for the extraordinary fertility of the soils of the American Midwest. The famous black earth of Iowa, Illinois, and Kansas was built by the prairie over millennia and is among the most productive agricultural soil in the world. The bison were the keystone species of the plains ecosystem, their grazing, wallowing, and movement shaping vegetation in ways that maintained the prairie's ecological structure. They were not simply inhabitants of the prairie, they were its co-creators. Their trails became the routes that settlers would follow westward. Their migrations moved nutrients and seeds across vast distances. Their wallows created small wetland features that supported distinct communities. Without the bison, the prairie was not the same ecosystem. The destruction of both the prairie and the bison in the 19th century was extraordinarily rapid. By 1890, the bison had been reduced from tens of millions to fewer than 1,000 individuals, hunted to near extinction in 2 to 3 decades, partly commercial slaughter and partly deliberate policy to undermine the indigenous cultures whose existence depended on the herds. Today, less than 4% of the original tallgrass prairie survives, making it one of the most endangered ecosystems on Earth. An ocean of grass replaced by the crops that grow in the deep soils the prairie spent thousands of years creating. Fact 36. The lost megafauna of the Americas, giants erased at the dawn of civilization. When the first human beings crossed the Bering Land Bridge and entered North and South America, most likely between 15,000 and 20,000 years ago, they entered continents teeming with large animals that had never encountered human hunters before. The Americas of the late Pleistocene were a world of giants. Enormous ground sloths the size of elephants, horses and camels that had actually originated in North America, saber-toothed cats with canine teeth 20 centimeters long, American mastodons and mammoths, short-faced bears larger than modern grizzlies, and dozens of other large and spectacular species now entirely absent from the Western Hemisphere. The scale of the American megafauna extinction is staggering. North America lost approximately 35 genera of large animals, roughly 70% of its large mammal diversity, between approximately 13,000 and 10,000 years ago, in geological terms an almost instantaneous event. South America's losses were even more dramatic, with approximately 50 genera of large mammals vanishing over a similar timeframe. Among the most spectacular losses were the giant ground sloths. Megatherium americanum in South America could reach 6 meters in length and weigh up to 4 tons, browsing on tree leaves it pulled down with enormous curved claws. The glyptodonts, enormous armadillo, relatives the size of small cars, covered in a dome of bony armor, also disappeared in this wave of extinctions. The timing of the extinctions closely parallels the arrival and spread of human populations across the Americas, a correlation that has convinced many researchers that human hunting was the primary driver. The overkill hypothesis, developed most prominently by paleontologist Paul Martin, proposes that the American megafauna had no fear of people and could be killed at rates exceeding their reproductive capacity. Unlike the fauna of Africa and Eurasia, which had co-evolved with human hunters and had time to develop appropriate wariness, the American animals were naive prey. Today, the Americas are notable among the world's major landmasses for the relative poverty of their large mammal fauna. Africa's savannas, with their elephants, hippos, rhinos, and giraffes, represent something much closer to the natural richness that once characterized all of the world's major landmasses. The pampas of South America, the plains of North America, these are landscapes emptied of their giants, ecosystems operating in the permanent absence of the large animals that once shaped them. Fact 37, Lake Agassiz, the largest lake that ever existed in North America. At the height of its extent, approximately 10,000 years ago, Lake Agassiz was the largest lake in North American history, a body of water far exceeding anything that exists on the continent today, covering approximately 1.5 million square kilometers across what are now the prairies of Manitoba, Saskatchewan, Ontario, and portions of Minnesota and North Dakota. It was not a permanent geological feature, but a glacial lake, a temporary body of water created by the melting of the Laurentide ice sheet, dammed on its northern edge by the retreating glacier, and filling the vast, flat lowlands of the interior plains with meltwater that had nowhere else to drain. Lake Agassiz was created and sustained by the extraordinary volumes of meltwater produced as the Laurentide ice sheet retreated northward. As the glacier melted, the meltwater pooled behind the remnant ice, which acted as a natural dam. The flat topography of the interior plains, itself shaped by millions of years of glacial erosion and sediment deposition, meant that the lake spread laterally across an enormous area rather than cutting deeply into bedrock. The bottom of Lake Agassiz was largely fine-grained glacial sediment, the same material that today forms the famous black soils of Manitoba and Saskatchewan, some of the most productive agricultural land in the world. Lake Agassiz rose and fell dramatically as the balance between glacier melt and drainage shifted over thousands of years. At various times, it drained southward through the Minnesota River Valley and the Mississippi system into the Gulf of Mexico, or eastward through the Great Lakes into the St. Lawrence River and the Atlantic. One particularly significant drainage event, approximately 8,200 years ago, may have released an enormous pulse of cold freshwater into the North Atlantic, contributing to a brief but significant global cooling episode detectable in ice core and ocean sediment records around the world. When the Laurentide ice sheet retreated far enough to unblock a northern drainage route into Hudson Bay, Lake Agassiz drained catastrophically, one of the largest single freshwater floods of the Holocene. The lake basin it left behind is not empty. Today it is occupied by Lakes Winnipeg, Winnipegossis, and Manitoba, small remnants of what was once the continent's greatest lake. The flat, fertile prairies of the Canadian interior are the drained floor of Lake Agassiz, its legacy visible in every field of wheat and every unbroken horizon. Fact 38, the dodo, how an island became a death trap. The dodo is perhaps the most famous extinct species in the world, more famous, arguably, than any living species, its image instantly recognizable, its name a synonym for extinction itself. The phrase "as dead as a dodo" has entered the English language as an expression for something irreversibly, completely gone. And the dodo did go in exactly this way, completely, irreversibly, and with a speed that shocked even the people who caused its extinction. From the first recorded European encounter with the species in 1598 to the last confirmed sighting in 1662, the dodo was gone in less than 65 years, a geological instant, a human lifetime, a historical eye blink. The dodo did not die slowly, it was erased. The dodo, Raphus cuculatus, was a large, flightless bird endemic to the island of Mauritius in the Indian Ocean, a relative of pigeons that had evolved over millions of years in complete isolation from mammalian predators. Mauritius had no native land mammals before human arrival, and the dodo had no evolutionary reason to fear ground-dwelling animals, no reason to flee, no reason to defend itself, no reason to nest anywhere other than the ground. It was not stupid, despite its reputation. It was simply evolved for an island world that had never contained anything that wanted to eat it. When Dutch sailors arrived on Mauritius in 1598, they found an island teeming with a completely tame bird that walked toward them out of curiosity. The dodo was large, roughly a meter tall, and weighing perhaps 10 to 18 kilograms, and provided a substantial meal. It could be killed with virtually no effort. The sailors described it as not particularly delicious, but easy. More fatally for the dodo, the Dutch colonization of Mauritius introduced the animals that would ultimately cause its extinction not through direct hunting, but through indirect ecological catastrophe. Rats, pigs, macaques, and dogs, all of which preyed on the dodo's ground-laid eggs and chicks. No complete dodo specimen survives, only partial skeletal remains. A few preserved soft tissue fragments and contemporary illustrations and descriptions. We know it existed, we know it went extinct, we have a rough sense of what it looked like. Everything else about its ecology, behavior, and biology is reconstructed from incomplete evidence and inference. The dodo is a ghost defined by absence, a creature whose extinction was so rapid and so complete that it left behind barely enough evidence to confirm it ever lived at all. Fact 39. The lost kelp forests, vanished underwater cathedrals. Beneath the surface of the cold, nutrient-rich coastal waters of the world's temperate and subpolar oceans, the Pacific coasts of North and South America, South Africa and Australia, the coasts of southern Europe and New Zealand, there grow forests of extraordinary beauty and biological complexity. Kelp forests are among the most productive ecosystems on Earth, their towering fronds of giant kelp reaching 45 meters in length and growing at rates of up to 60 centimeters per day, creating a three-dimensional habitat of extraordinary complexity that supports hundreds of species of fish, invertebrates, and marine mammals. These forests are ancient. They are also in many parts of the world disappearing, and in some places already gone. The ecological importance of kelp forests is difficult to overstate. Like tropical rainforests on land, kelp forests create layered habitats, from the sunlit canopy at the surface to the dim understory below, to the rocky seafloor in which different species occupy different ecological niches. Sea otters, sea lions, harbor seals, and hundreds of fish species depend on kelp forests for food and shelter. The forests dampen wave energy, protecting coastlines from erosion. Their enormous productivity exports organic material into the deeper ocean, supporting food webs far beyond the forest itself. Kelp forests have come and gone throughout coastal history in response to changes in ocean temperature, nutrient availability, and grazer populations. Warming ocean temperatures have caused dramatic kelp forest declines in multiple regions in recent decades. Off the coast of Northern California, kelp forest coverage declined by over 95% between 2014 and 2020, driven by a marine heat wave that destabilized the ecological balance kelp forests depend on. Similar collapses have been documented in Australia, Norway, and other regions. What makes these contemporary losses particularly significant is that they are happening against a background of long-term ecological degradation. The historical baseline of kelp forest health, the state of these ecosystems before industrial fishing, pollution, and climate change began affecting them, was substantially richer than what exists today, even in areas where kelp forests are still present. We are measuring the decline of kelp forests against an already diminished baseline, and the original forests, the kelp cathedrals that existed before human impacts began, are as lost to us as any ancient ecosystem. Fact 40. The Holocene megafauna, the animals that almost made it. The Holocene epoch, which began approximately 11,700 years ago, is also an epoch of biological impoverishment, a period of ongoing megafauna extinction that began at the end of the Pleistocene and has continued at varying rates ever since. The Holocene extinction is not ancient history. It is the epoch we are living through right now, and its pace is accelerating rather than slowing, driven by the expanding footprint of human civilization across across every remaining wild landscape on Earth. The most recent large mammal to go extinct before the modern industrial era was probably Steller's sea cow, a relative of the dugong and manatee that inhabited the cold waters of the North Pacific. Discovered by Europeans in 1741, when Vitus Bering's expedition was shipwrecked on Bering Island, Steller's sea cow was enormous, reaching up to 8 or 9 meters in length and weighing several tons, and completely tame around boats. The stranded crew survived largely by eating it. Once its location became known to hunters and fur traders, it was hunted to extinction in less than 27 years. The last Steller's sea cow was killed in 1768. The pattern of Holocene megafauna extinctions follows the pattern of human expansion and intensification. Islands were the most vulnerable. Wherever human beings arrived on islands with no prior experience of human hunters, the large, tame, ground-nesting animals were quickly exterminated. The moa of New Zealand, enormous flightless birds reaching 3 meters in height, went extinct within approximately 200 years of Polynesian arrival, around 1300 CE. The elephant birds of Madagascar, the largest birds that ever lived, their eggs 6 times the size of an ostrich egg, were extinct by the 17th or 18th century. The giant tortoises of the Indian Ocean islands, the giant lemurs of Madagascar, the hippos of Cyprus, all gone in the Holocene, within human historical memory. We are living inside an extinction event. The rate of species loss is estimated to be 100 to 1,000 times the background rate that prevailed before human influence became dominant. The animals going extinct today are not the casualties of ancient geological change, but of choices being made in the present moment, in our lifetimes. The Holocene megafauna extinction is not finished. It is continuing right now while the world sleeps. You are halfway through the journey now. 50 worlds wait behind you in the dark: drowned continents, vanished glaciers, extinct giants, collapsed forests, lost seas. In this 5th part, we move between scales from the grandest experiments in ecological restoration ever attempted to the ghost forests of the present day. You have come a long way. Rest now and let the second half begin. This is Explore During Sleeping. Fact 41. The Lost Coral Triangle, when reefs ruled the ancient ocean. The Coral Triangle, the vast region of tropical ocean spanning the waters of Indonesia, the Philippines, Malaysia, Papua New Guinea, the Solomon Islands, and Timor-Leste, is today considered the global center of marine biodiversity, sometimes called the Amazon of the seas. Its waters contain more species of fish, coral, and marine life than anywhere else on Earth. But this extraordinary living system represents only a shadow of what coral reefs have been in the deep history of the ocean, and the ancient reef ecosystems of the geological past reveal that even the richest marine environment on Earth today is impoverished compared to what once existed in the warm, shallow seas of ancient geological periods. The history of coral reefs spans more than 500 million years, but the corals that build today's reefs, the reef-building scleractinian corals, are relatively recent arrivals, appearing approximately 240 million years ago after the Permian mass extinction wiped out the previous dominant reef-building organisms. Before the scleractinian corals, reefs were built by entirely different organisms: stromatoporoids, tabulate corals, rugose corals, and other groups that dominated the shallow seas of the Silurian and Devonian periods. These ancient reefs vanished in the mass extinctions that punctuated the Paleozoic era, replaced by new organisms that rebuilt similar ecological structures from different biological foundations. The most spectacular ancient reef system we know of is the reef tract of the Devonian period, approximately 385 million years ago. In what is now the Canning Basin of Western Australia, the ancient Devonian reef is preserved in extraordinary detail in the Kimberley region, its fossilized structures exposed at the surface after hundreds of millions of years of geological uplift and erosion. This ancient reef rivaled the Great Barrier Reef in scale, stretching for hundreds of kilometers, built by organisms that no longer exist, preserved in rock that was once warm, clear tropical seawater. Every major mass extinction has devastated reef ecosystems. Reefs are among the first ecosystems to collapse when ocean chemistry changes or temperatures rise. After each extinction, it has taken tens of millions of years for reef ecosystems to recover their pre-extinction complexity. The current threat to modern coral reefs from warming temperatures and acidification represents another in this long series of reef crises, but one that is occurring faster than any previous natural disruption in the history of reef ecosystems. Fact 42. The Triassic Rebound, life's greatest recovery. The Permian mass extinction, the great dying that eliminated 96% of marine species and 70% of land vertebrates approximately 252 million years ago, was not the end of life's story. It was the beginning of a new chapter, one of the most dramatic in the history of life on Earth. The recovery from the Permian extinction, known as the Triassic rebound, took approximately 5 to 10 million years and produced a world radically different from the one that had preceded it. A world in which entirely new groups of organisms rose to dominance from the ashes of the greatest catastrophe life had ever faced. The immediate aftermath of the Permian extinction was a world of extreme biological simplicity. The ocean floors were largely lifeless. On land, one species, Lystrosaurus, a stocky, pig-like herbivore, was so overwhelmingly dominant in the earliest Triassic that some fossil sites consist almost entirely of its remains, representing perhaps 95% of all land vertebrate fossils from this period. The ecological diversity that had characterized the Permian world, the complex food webs, the diverse plant communities, the variety of predator and prey, had collapsed into something almost unrecognizably simplified. From this extreme simplicity, life rebuilt. Over millions of years, the survivors diversified and radiated into the empty ecological niches left by the mass extinction. New groups rose to prominence. The archosaurs, which would eventually split into the crocodilian lineage and the lineage that led to dinosaurs and birds, the first mammals, which evolved from the surviving therapsids, the first true turtles, the first flying vertebrates, the pterosaurs, which took to the air in the late Triassic. Marine ecosystems were rebuilt by new groups of predators, new reef-building organisms, and new planktonic communities. The Triassic rebound is the most thoroughly studied example of ecosystem recovery after a mass extinction, and its lessons are simultaneously hopeful and sobering. Life did recover, comprehensively, spectacularly, producing a world of extraordinary diversity and complexity. But the recovery took millions of years, and the world that emerged from the Triassic was not a restoration of the Permian world, but an entirely new creation, built from different species, organized around different ecological relationships. The world that was lost in the Permian never came back. A different world grew in its place. Fact 43. The lost savannas of Europe, when lions prowled the Thames. In the popular imagination of deep prehistory, Europe is defined by ice, by the great glaciers of the Ice Age, the cave paintings of southern France, the woolly mammoths and Neanderthals of the frozen north. But this image represents only the most recent and most dramatic of the many ecosystems that have covered Europe over the past million years. During the warm interglacial periods that punctuated the Ice Age, periods when temperatures in northwestern Europe were somewhat warmer than today, Europe was a very different kind of place. A landscape of open woodland and savanna, dotted with animals that modern Europeans associate entirely with Africa. The warm interglacial known as the Eemian, approximately 130,000 to 115,000 years ago, was a period when global temperatures were somewhat higher than today, and the fauna of what is now Britain and northern Europe included hippopotamuses wallowing in the Thames and Rhine, straight-tusked elephants larger than any modern African elephant browsing in the forests of what is now Germany, spotted hyenas denning in the limestone caves of southern England, and lions. Lions larger than modern African lions, a now extinct species called Panthera leuspelia, hunting across the open grasslands of what would one day become the agricultural heartland of Europe. The fossil evidence for this lost European savanna is abundant and specific. Hippopotamus bones have been found in the gravels of the Thames at multiple locations in London, and straight-tusked elephant remains have been recovered from sites across Britain and continental Europe. At Trafalgar Square in London, now one of the busiest urban spaces in the world, excavations in the 19th century recovered the bones of hippopotamus, straight-tusked elephant, woolly rhinoceros, and lion from interglacial river sediments deposited when the Thames was a slow, warm, hippopotamus-haunted river flowing through open woodland. The fauna of the Eemian interglacial was not limited to these large and spectacular species. The full ecological community included fallow deer, aurochs, wild boar, brown bear, wolves, and a diverse array of smaller mammals, birds, and insects. The vegetation was a mosaic of open oak woodland, grassland, and wetland, supporting the same kind of complex herbivore community that today survives only on the African savanna. When the Eemian ended and the ice returned, this entire ecosystem was pushed southward and greatly reduced, leaving only cave paintings and bones in the Thames gravel as its memory. Fact 44. The ancient Amazon, how the world's greatest river evolved. The Amazon River Basin is not just the largest river system on Earth by water volume. It is one of the most biodiverse regions in the history of life, a landscape of such ecological complexity that it contains perhaps 10% of all the species currently living on Earth. This extraordinary richness is partly a product of the Amazon's current size and productivity, but it is also a legacy of the basin's extraordinary geological and climatic history, a history of fragmentation and reconnection, of ice age contractions and interglacial expansions, of isolation and reunion that produced new species in each separated fragment, and then mixed them together when the fragments reconnected. We explored earlier how the Amazon was once an inland sea, the Pebas system, and how the rise of the Andes redirected its drainage toward the Atlantic. But the story of the Amazon's biodiversity has a more recent chapter, playing out during the ice ages of the past 2 million years. During the cold, dry glacial periods, when the Amazon basin received less rainfall and temperatures were lower, the vast Amazon rainforest contracted into a series of isolated refugia, islands of forest, separated by corridors of savanna and dry woodland that the forest animals could not easily cross. These refugia served as evolutionary crucibles, isolated pockets where populations of animals and plants evolved independently for thousands of years, accumulating genetic differences that would eventually make them distinct species. When the climate warmed and the forest expanded to reconnect the refugia, the newly differentiated species met again, and in the richly mixed zone where former refugia connected, the density of species was highest. This refugia theory, proposed by Eugen Hafer in 1969, has been refined and debated extensively, but the basic pattern, that Ice Age forest fragmentation contributed significantly to the Amazon's extraordinary species richness, is now widely accepted. The Amazon today is losing forest at unprecedented rates. Each year, an area roughly the size of Switzerland is cleared for agriculture, cattle ranching, and other uses. The ecological consequences extend far beyond the species directly inhabiting the cleared areas. The Amazon drives rainfall patterns across much of South America, and there is evidence that deforestation beyond a certain threshold could trigger a tipping point, converting large portions of the remaining forest to savanna in a self-reinforcing process that climate scientists call Amazon dieback. Fact 45: the lost whales when the ocean giants swam inland. Today, whales are entirely marine animals, the largest creatures ever to have existed on Earth, fully adapted to life in the ocean, their ancestors' land-living past visible only in the vestigial finger bones hidden within their flippers. But whales have not always been ocean dwellers. They evolved from land-living ancestors approximately 50 million years ago in the warm, shallow Tethys Sea that once covered what is now Pakistan and India, and the fossil record of whale evolution preserved in the rocks of what is now the Himalayan foothills tells one of the most dramatic evolutionary stories in the history of life, the story of how a wolf-sized land mammal became the largest creature in the history of the Earth. The earliest whale ancestors, collectively called archaeocetes, are known from extraordinary fossils discovered in Pakistan, Egypt, and other countries bordering the ancient Tethys. Pakistus, approximately 50 million years old, was a wolf-sized, four-legged land mammal with hooves, distantly related to modern even-toed ungulates like hippos and deer. It lived on riverbanks and waded into shallow water to hunt fish, its ears already showing the beginning of the modifications that would enable underwater hearing. Over the next 15 million years, its descendants became progressively more aquatic, their hind limbs shrinking, their bodies elongating, their nostrils migrating backward to become blowholes. Basilosaurus, discovered in the Eocene rocks of Egypt and the southeastern United States, was already fully aquatic, reaching lengths of 15 to 20 meters, with a long, snake-like body and reduced hind limbs too small to support its weight on land. Basilosaurus swam through warm, shallow seas that covered what is now the Egyptian Sahara, the same region that is today one of the world's most completely desolate and lifeless landscapes, containing within its bleached rock the bones of swimming giants. The great whales of today are the survivors of a whale diversity that was once much greater. Ancient whale species included forms of extraordinary variety, from the filter-feeding ancestors of modern baleen whales to echolocating toothed whales to bizarre forms with asymmetrical teeth and body plans unlike anything living today. Many of these lineages were eliminated by the climate changes and oceanographic reorganizations of the Neogene period. The ocean giants we see today are the remnants of a once far richer world of cetacean diversity. Fact 46: the lost forests of Britain, the wildwood that was. Before the arrival of Neolithic farmers approximately 6,000 years ago, the island of Britain, from its southern chalk downs to its northern highlands, was covered by a dense, continuous forest that ecologists call the wildwood, a term coined by the botanist Oliver Rackham to describe the post-glacial forest that covered Britain after the retreat of the last ice age. The wildwood was not a uniform blanket of trees, but a complex, varied, and extraordinarily rich ecosystem, a mosaic of oak and hazel woodland, lime forest, ash woodland on thin soils, alder in the wetlands, and in the north, birch and pine forest, covering virtually every acre of land that was not too high, too wet, or too rocky to support trees. The wildwood supported an ecological community that was, by modern standards, extraordinary in its richness and completeness. Aurochs, the wild ancestors of domestic cattle, standing 2 meters at the shoulder, browsed through the open glades. European brown bears, wolves, lynx, wild boar, and beavers all inhabited the forest. The rivers were full of salmon, sea trout, and beaver-dammed ponds. The forest floor was thick with wildflowers and insects in numbers that modern naturalists can barely imagine. The bird life included species that have long since been extirpated from Britain: white-tailed eagles, ospreys, cranes, white storks, and the now extinct great bustard. The destruction of the British wildwood began with Neolithic farming, but accelerated dramatically through the Bronze Age, Iron Age, and Roman period, as increasing populations required more farmland, more timber for building and fuel, and more pasture for growing livestock herds. By the time of the Domesday Book survey in 1086 CE, only approximately 15% of England's land area was still forested. Today, Britain is one of the least forested countries in Europe, with only about 13% forest cover, and much of that is commercial plantation of non-native conifers, ecologically almost barren compared to the ancient mixed woodland it replaced. The wildwood that once covered Britain is preserved only in scattered fragments, ancient woodland sites where the soil has never been ploughed, recognizable by their characteristic ground flora of bluebells, wood anemones, and wild garlic that takes centuries to establish. These fragments are the last living remnants of a forest world that once covered an entire island, still being lost to development and neglect. The wildwood is one of the most thoroughly erased ecosystems in Europe's long history of human land use. Fact 47, the Eocene thermal maximum, when the Arctic was a tropical sea. Approximately 56 million years ago, the Earth experienced one of the most abrupt natural global warming events in the geological record. A sudden spike in global temperatures, known as the Paleocene thermal maximum, or PTM, that raised global average temperatures by approximately 5 to 8 degrees Celsius within perhaps 20,000 years. The trigger was a massive release of carbon dioxide and methane into the atmosphere. The source is debated, with candidates including volcanic activity, the destabilization of frozen seafloor methane hydrates, or both. The PTM lasted approximately 200,000 years before temperatures returned to pre-event levels, the most dramatic natural carbon release of the past 66 million years, producing a world of extraordinary warmth with no modern analog. During the PTM and the broader warm period of the early Eocene that followed, global temperatures were dramatically higher than today. There were no ice caps at either pole. Forests grew in Antarctica and the high Arctic. Palm trees and alligators lived in what is now Ellesmere Island in the Canadian high Arctic, above 80 degrees north latitude, a region that today is one of the most barren and frozen places on Earth. The Arctic Ocean was not the frozen sea we know today, but a warm, brackish body of water covered for part of the year by mats of a small floating fern called azalea, whose growth consumed enormous quantities of carbon dioxide from the atmosphere. The azalea event, a period approximately 49 million years ago when azalea ferns grew explosively across the warm Arctic Ocean, is one of the most remarkable episodes in geological history. As the ferns grew and died and sank to the seafloor, they took with them the carbon they had fixed during photosynthesis, gradually reducing atmospheric carbon dioxide and contributing to the long-term cooling that would eventually lead to the formation of polar ice caps. The thick deposits of azalea organic matter on the Arctic Ocean floor are among the geological fingerprints of this ancient cooling event. The Eocene world, with its warm poles, its forests in the Arctic, its alligators on Ellesmere Island, is perhaps the best natural analogue for what a significantly warmer Earth looks like. Climate scientists study the Eocene intensively because it represents a warm Earth state that was eventually habitable for complex life. But the transition to that warm state and the biological disruption that accompanied the PTM serves as a reminder that rapid warming, even when followed by eventual habitability, always carries profound ecological costs. Fact 48, the lost seagrass meadows, vanished underwater pastures. Beneath the shallow, sunlit waters of the world's coastal seas, in the calm bays and lagoons and sheltered inlets from the tropics to the temperate zones, there grow meadows of seagrass, flowering plants that returned to the ocean approximately 100 million years ago, and that today form some of the most productive and ecologically important ecosystems on the planet. Seagrass meadows are the feeding grounds of dugongs, manatees, green sea turtles, and countless fish species. They are among the most effective carbon sinks on Earth, storing carbon at rates per unit area far exceeding tropical rainforests. They are nurseries for many commercially important fish species, and they are disappearing from coastlines around the world at rates faster than tropical rainforests. Seagrasses are not algae. They are true flowering plants with roots, stems, leaves, and flowers that colonized the marine environment after their ancestors had already evolved on land. Their evolutionary return to the sea is one of the most dramatic examples of secondary aquatic adaptation in the history of life, paralleling the evolution of whales from land mammals. Today, approximately 60 species of seagrass grow in coastal waters worldwide, forming meadows that in some places cover hundreds of square kilometers of shallow seafloor. The ecological importance of seagrass meadows became particularly clear as they began disappearing. In coastal areas where seagrass meadows have been lost, due to water quality degradation from agricultural runoff, coastal development, increased turbidity from dredging, and climate change, the ecological consequences cascade through entire coastal ecosystems. Fish populations decline. Dugong populations collapse when their feeding grounds disappear. Coastal sediments destabilize without the anchoring effect of seagrass roots. Carbon stored for centuries in seagrass sediments is released as the sediments are disturbed and oxidized. Global seagrass coverage has declined by an estimated 29% since the late 19th century, with the rate of loss accelerating. In some regions, the Mediterranean, parts of the Caribbean, portions of the Australian coast, losses have been particularly severe. What is lost is not merely habitat but function. The carbon storage, the nursery habitat, the sediment stabilization, the water filtration that seagrass meadows provide. The disappearing seagrass meadows are among the least visible and least mourned of the world's vanishing natural worlds. Fact 49, the Pleistocene Park Experiment, bringing back a lost world. In the far northeast of Siberia, in the remote Yakutia region, where the permafrost runs hundreds of meters deep and the summers are brief and intense, a Russian ecologist named Sergei Zimov has been conducting one of the most audacious ecological experiments in history. Since 1996, Zimov and his son Nikita have been attempting to recreate the mammoth steppe, the lost grassland ecosystem that covered much of the northern hemisphere during the Ice Age and vanished 12,000 years ago. They call their project Pleistocene Park, and their goal is not merely academic. It is urgently practical, aimed at slowing the thaw of one of the Earth's most critical carbon stores. The rationale behind Pleistocene Park is rooted in the relationship between large herbivores and permafrost. The permafrost of Siberia, frozen ground containing enormous quantities of organic carbon accumulated over tens of thousands of years, is one of the most significant potential sources of greenhouse gas emissions in the context of climate change. As the Arctic warms and the permafrost thaws, the organic material within it begins to decompose, releasing carbon dioxide and methane in a self-reinforcing feedback loop that could dramatically accelerate global warming. Zimov's insight is that large herbivores can help preserve permafrost by trampling the insulating snow cover in winter, exposing the frozen ground to the frigid Arctic air and keeping it frozen. On the mammoth steppe, enormous herds of bison, horses, and other herbivores compacted snow through their constant movement, maintaining deep, stable permafrost. Without the herbivores, snow accumulates in thick, insulating layers that prevent the cold from penetrating the ground, allowing the permafrost beneath to warm and eventually release its stored carbon. Pleistocene Park currently hosts horses, bison, musk ox, reindeer, moose, and other large herbivores introduced from various parts of the world, slowly building up the animal populations and ecological processes that might eventually resemble something like the mammoth steppe. The project envisions eventually introducing predators, and perhaps a genetically engineered cold-adapted elephant to fill the mammoth's ecological role. Whether this experiment can ultimately succeed is uncertain, but as a practical response to the threat of permafrost thaw, it represents one of the most creative and thought-provoking attempts in history to bring a vanished world back to life. Fact 50, the living dead, ghost ecosystems, and what they teach us. In ecology, there is a concept called extinction debt, the idea that when a habitat is destroyed or fragmented, not all the species that depended on it go extinct immediately. Some survive for a time in remnant habitat, or in small, isolated populations that are no longer viable in the long run but have not yet disappeared. These species are ecologically doomed but physically present, the living dead of the natural world, species already committed to extinction by the loss of the habitat that sustained them, simply waiting for the last member of a doomed population to die. The ecosystems they inhabit are sometimes called ghost ecosystems, functioning in some superficial sense, but lacking the ecological relationships that once gave them complexity and resilience. The concept of extinction debt helps explain why seemingly intact-looking natural areas can feel impoverished. why a forest that looks green and continuous seems curiously quiet, strangely empty, oddly simplified. What they are often experiencing is a ghost ecosystem, a landscape whose visible structure still stands but whose ecological content has been partially evacuated by habitat loss, hunting, or other human pressures. The large predators that once structured the food web are gone. The migratory species that once connected it to distant landscapes no longer arrive. The species interactions that maintained complexity have been severed. This concept has profound implications for conservation. It means that protecting a fragment of habitat today does not guarantee the long-term survival of the species currently living in it. It may merely delay their extinction. It also means that the extinction crisis we are currently experiencing is worse than the current rate of confirmed extinctions suggests, because the extinctions caused by today's habitat destruction have not yet fully manifested. We are accumulating an extinction debt that future generations will be forced to pay. But extinction debt also points toward hope. If species can persist for decades in degraded habitats, conservation and habitat restoration efforts have a window, a period during which species committed to extinction by past habitat loss can still be saved if their habitat is restored. The living dead can sometimes be brought back to life. The ghost ecosystems can, under the right conditions and with sufficient human commitment, be haunted once more by the species that gave them their original richness and made them truly alive. Fact 51. The lost rivers of Britain, waterways that vanished underground. Britain's landscape today is defined by its rivers, the Thames, the Severn, the Trent, the Avon, and the countless smaller streams that have shaped human settlement patterns, powered mills, and given their names to towns and cities for thousands of years. But Britain's river network is not fixed and permanent. It has changed dramatically over geological time, and even over human historical timescales. Rivers have been redirected, buried, lost, and in some cases entirely forgotten beneath the urban landscapes that grew over them. The lost rivers of Britain are windows into the layered history of a landscape, continuously reshaped by both natural and human forces. The most dramatic changes to Britain's river network occurred at the end of the last ice age, when the melting of the British ice sheets and the sea level rise that flooded Doggerland fundamentally reorganized the drainage patterns of the entire island. Rivers that had previously flowed northeast across the Doggerland plain were cut off as sea levels rose and their lower reaches were flooded. New coastlines formed where previously there had been river valleys, and the rivers that now flow into the North Sea and the English Channel established their present courses only in the past few thousand years. Within Britain's cities, dozens of rivers have been buried beneath the urban fabric, culverted, redirected underground, or simply built over as cities expanded across their former floodplains. London alone contains approximately 20 significant rivers that now flow entirely underground: the Fleet, the Walbrook, the Effra, the Westbourne, the Tyburn, and others whose names survive in street names and pub names across the city, but whose waters are confined to Victorian sewers far below the surface. The Fleet River, once wide enough to be navigable by boats, now flows through a sewer beneath Farringdon Road, emerging into the Thames invisibly and underground. These buried rivers occasionally make their presence known, in the periodic flooding of basements and underground stations along their former courses, in patches of unexpectedly lush vegetation that appear along their buried lines, and in subtle topographic undulations in flat urban landscapes that mark ghost valleys of vanished watercourses. In recent decades, a growing movement has advocated for the daylighting of these rivers, removing their culverts and allowing them to flow once again at the surface, restoring the natural character of landscapes that centuries of urban development have buried but not erased. Fact 52. The lost grasslands of China, steppes turned to desert. Across the vast interior of northern China, across Inner Mongolia, Gansu, Ningxia, and portions of Hebei and Shanxi, there stretches a landscape of eroding gullies, shifting sand dunes, and bare, wind-scoured plains collectively referred to as China's expanding deserts. Gobi Desert and the Muir Sandy Land expand year by year, generating the massive dust storms that periodically blanket Beijing in orange haze and deposit Chinese soil across Korea, Japan, and sometimes even North America. This expanding desertification is partly natural, but is predominantly the result of human land use choices made over the past century that converted enormous areas of ancient grassland into farmland, and then watched as the degraded soils blew away. Before the large-scale agricultural expansion of the 20th century, much of what is now desert or severely degraded land in northern China was grassland, the eastern extension of the Great Eurasian Steppe stretching from Hungary to Manchuria, a vast, semi-arid grassland ecosystem supporting mobile pastoral cultures, enormous herds of wild horses and antelopes, and a complexity of wildlife now largely gone. The Mongolian gazelle, which once numbered in the millions and migrated in vast herds, has been reduced to a fraction of its former population as the grasslands were converted to farmland and migration routes blocked by fencing, roads, and railways. The conversion of Chinese grasslands to farmland produced one of the largest desertification events of the 20th century. Without the deep root systems of native grasses to hold the thin, dry soil in place, the exposed agricultural soil dried and eroded. Wind removed the fine particles, leaving behind the coarser sand and gravel that forms the advancing dune fields visible across northern China today. The process, once initiated, is self-reinforcing. Less vegetation means less moisture retention, which means less vegetation, which means more erosion. In recent decades, China has invested enormous resources in anti-desertification programs, massive tree planting projects, grassland restoration efforts, and the relocation of farming communities away from the most degraded areas. The results are mixed. Some areas have shown genuine recovery, while others have found that planted trees in areas too dry to support them simply die, doing little to restore the original grassland ecology. The lost grasslands of northern China are a reminder that converting ancient ecosystems to farmland is far easier than reversing the ecological damage that follows. Fact 53: the lost megafauna of Madagascar, the island where giants survived longest. Madagascar, the great island off the east coast of Africa, fourth largest island on Earth, home to approximately 90% of wildlife found nowhere else, is famous today for its extraordinary endemic biodiversity. Its lemurs, its baobab trees, its chameleons, its tenrecs, its fosses. This living diversity, remarkable as it is, represents only a fraction of what Madagascar contained before human arrival approximately 2,000 years ago. The Madagascar that Austronesian settlers first encountered when they crossed the Indian Ocean from Indonesia was an island of giants, creatures of extraordinary size and strangeness that had evolved in isolation for 88 million years, and that would be driven to extinction within 1,000 years of the first human footfall on the island. The giant lemurs of Madagascar were among the most spectacular. Archaeondrus fontenontii, the sloth lemur, was the largest primate to have lived outside of Africa and Asia, weighing approximately 200 kilograms, larger than a male gorilla, moving slowly through the forests like a massive sloth. Megalodapes edwardsi was another enormous lemur, up to 85 kilograms, with a skull shaped more like a koala's than a primate's, adapted for browsing on tough leaves. Smaller but still large species included Paleopropithecus, which hung upside down in trees like modern sloths. All of these giant lemurs were gone within approximately 500 years of sustained human presence on the island. Perhaps the most famous of Madagascar's vanished giants were the elephant birds, Aepyornis maximus and related species. These enormous ratites stood up to 3 meters tall, weighed up to 500 kilograms, and laid the largest eggs of any bird that has ever lived. A single egg could contain 8 liters of fluid, equivalent to approximately 150 chicken eggs. The elephant birds were the largest birds that ever lived, and their extinction, probably by the 17th or 18th century, removed from the world one of the most spectacular animals of the Holocene. Madagascar has also lost giant tortoises, pygmy hippos, aardvarks, and a diverse community of large mammals and birds that are known only from their subfossil remains. The island that remains, extraordinary as it is a ghost of the world it was before human arrival. And that remaining extraordinary world is itself under severe pressure. Madagascar has lost approximately 90% of its original forest cover, and the lemurs and other endemic animals that still survive are among the most threatened groups of animals on Earth. Fact 54: the lost wetlands of Europe, the draining of a continent. Across Europe, from the fens of eastern England to the marshes of the Danube Delta, from the peat bogs of Ireland to the coastal wetlands of the Baltic, there once existed an extraordinary mosaic of wetland habitats, fens, bogs, marshes, swamps, river floodplains, and estuaries, covering many millions of hectares and supporting some of the richest wildlife communities on the continent. These wetlands were the ancient nurseries of European biodiversity, breeding grounds for vast numbers of waterbirds, feeding grounds for migratory species, habitats for unique communities of plants, insects, amphibians, and fish. They are largely gone, drained, converted to farmland, built upon, or so degraded that they function as ecological shadows of what they were. The draining of European wetlands accelerated dramatically in the 18th, 19th, and 20th centuries as agricultural technology, particularly the development of powerful pumps, made it possible to drain previously inaccessible areas. The English Fens, a vast low-lying area in eastern England covering approximately 4,000 square kilometers, once one of the most productive and biodiverse wetland systems in northwestern Europe, supporting cranes, bitterns, spoonbills, and countless other species, were almost entirely drained between the 17th and 19th centuries and converted to some of the most productive agricultural land in Britain. The Mesopotamian marshes, the great wetlands of southern Iraq at the confluence of the Tigris and Euphrates rivers, were one of the world's largest inland wetland systems, covering approximately 20,000 square kilometers and supporting a unique culture, the Marsh Arabs, who had lived among the reeds in floating villages for thousands of years. During the 1990s, the Saddam Hussein government drained approximately 90% of the marshes through a massive engineering program, destroying both the ecosystem and the human culture that depended on it. The loss of European and Middle Eastern wetlands has consequences far beyond the wildlife communities they supported. Wetlands are among the most effective natural carbon stores on Earth, and their drainage releases enormous quantities of carbon dioxide and methane. The drained peatlands of Europe alone release hundreds of millions of tons of carbon dioxide each year. Wetland restoration is increasingly recognized as one of the most cost-effective tools for both biodiversity recovery and climate change mitigation, offering the rare possibility of simultaneously restoring wildlife habitat and storing carbon. Fact 55: the Devonian mass extinction, when fish nearly ended. The Devonian period, approximately 419 to 359 million years ago, is sometimes called the Age of Fishes, a time when the seas were dominated by extraordinary diversity of fish species, from the heavily armored placoderms to the first lobe-finned fishes whose descendants would eventually crawl onto land and give rise to all terrestrial vertebrates, including ourselves. The Devonian was also a period of remarkable innovation in the history of life. The first forests appeared on land, the first insects crawled through the newly formed leaf litter, and the first tetrapods made their tentative first steps onto dry land. And then, in one of the most prolonged and complex mass extinctions in Earth's history, approximately 75% of all species on Earth went extinct. The Late Devonian extinction, which occurred approximately 375 to 359 million years ago, was not a single event, but a series of extinction pulses spread over millions of years, one of the most extended mass extinctions in Earth's history. Its causes are still debated, but the current best understanding involves a complex combination of factors including cooling global temperatures, marine anoxia, the depletion of oxygen from ocean waters creating vast dead zones, and potentially the spread of land plants, whose roots began breaking down rock and releasing nutrients that fertilized algal blooms in coastal waters, consuming oxygen as they decomposed. The impact on marine life was catastrophic and selective. The placoderms, the heavily armored fish that had dominated the Devonian seas for tens of millions of years, were completely eliminated, along with approximately 70% of all marine invertebrate species. The reef ecosystems of the Devonian, which had been among the most productive and diverse in Earth's history, were devastated. The reef-building organisms that had constructed the Great Devonian reef systems went extinct, and it would take approximately 100 million years for reef ecosystems to fully recover. The Late Devonian extinction also profoundly affected the trajectory of vertebrate evolution. The extinction eliminated many of the competing lineages that might otherwise have diversified on land, potentially clearing the way for the tetrapod descendants of lobe-finned fishes to establish themselves as the dominant land vertebrates. The world that emerged from the Late Devonian extinction was in many respects the world from which our own lineage ultimately derives, a world shaped by one of the most prolonged ecological crises in the history of animal life. Fact 56: the lost megafauna of New Zealand, the moa and the Haast's eagle. New Zealand, the remote archipelago in the southwestern Pacific, separated from Australia by over 2,000 kilometers of open ocean, is one of the world's most remarkable examples of island evolution. Cut off from other landmasses for approximately 80 million years, New Zealand evolved a terrestrial ecosystem with almost no native land mammals, a gap filled by birds that evolved into roles typically occupied by mammals elsewhere. The moa, approximately 9 species of giant flightless birds, were the dominant large herbivores of New Zealand's forests and grasslands, and hunting them was the world's largest eagle, Haast's eagle, a predator of such power and size that it has no equivalent in the modern world. Moa ranged in size from the chicken-sized Euryapteryx curtus to the giant Dinornis robustus, which stood up to 3 meters tall and may have weighed 250 kilograms, the tallest bird that has ever lived, though the heavier elephant birds of Madagascar outweighed it. Moa were entirely flightless and had lost even the vestigial wings retained by other ratites such as ostriches and emus, over millions of years without mammalian predators, wings had become evolutionarily unnecessary. They browsed on the leaves, shoots, and fruits of New Zealand's forests, playing a crucial role in maintaining the forest ecosystem through their feeding and their role as seed dispersers. Hunting them from above was Haast's eagle, Hierarietus murray, the largest eagle known to have existed, with females reaching up to 15 kilograms in body weight and wingspans of up to 3 meters. Haast's eagle was a specialized moa predator, its talons disproportionately large and powerful, adapted for gripping and penetrating the thick muscles of a moa's hindquarters. Its relatively short, broad wings allowed it to navigate through dense forest at speed. The entire ecological relationship between Haast's eagle and the moa, predator and prey, had evolved over millions of years of island isolation. When Polynesian settlers arrived in New Zealand around 1280 CE, they began hunting the moa. The moa had no experience of human hunters and no behavioral defenses against them. Within approximately 200 years, by around 1450 CE, all 9 species of moa were extinct. Without the moa, Haast's eagle lost its prey base and went extinct shortly after. An entire ecological guild, the giant flightless herbivores and their specialized predator, was erased within 2 centuries of human arrival on an island where they had persisted for millions of years. Fact 57, the lost mangrove forests, the drowned trees that protected coastlines. Along the tropical and subtropical coastlines of the world, along the shores of Africa, Asia, the Americas, and the Pacific Islands, there grows one of the most distinctive and ecologically extraordinary ecosystems on Earth. Mangrove forests, tangles of salt-tolerant trees whose arching prop roots stand in the shallow water of the intertidal zone, straddling the boundary between land and sea in a way that no other major forest ecosystem does. Mangrove forests are simultaneously some of the most productive, most carbon-rich, and most threatened ecosystems on the planet, and they have been disappearing from tropical coastlines at alarming rates for decades, lost to shrimp farming, urban development, tourism infrastructure, and the rising sea levels that threaten to drown what remains. The ecological services provided by mangrove forests are remarkable and well documented. Their dense root systems act as physical barriers that dissipate the energy of waves and storm surges, providing coastal protection to the human communities behind them that is difficult and expensive to replace with engineered structures. The 2004 Indian Ocean tsunami caused dramatically less damage to communities protected by intact mangrove forests than to those where the forests had been cleared, and subsequent research confirmed that mangrove forests can significantly reduce tsunami wave heights and the distance that surge water penetrates inland. Mangroves are also among the most carbon-dense ecosystems on Earth. Their soils, waterlogged, anaerobic, and accumulated over centuries, store enormous quantities of organic carbon in forms that persist for millennia. When mangroves are cleared, this stored carbon is released, making mangrove deforestation one of the most carbon-intensive forms of land use change, emitting as much carbon per hectare as the clearing of tropical peat forests. Globally, mangrove forests store an estimated 6.4 billion tons of carbon, a quantity equivalent to years of global carbon emissions. The world has lost approximately 35 to 50% of its mangrove forests in the past 50 years, primarily to conversion for shrimp farming, coastal urban development, and unsustainable timber harvesting. In Southeast Asia, where mangrove diversity and density is highest, losses have been particularly severe. The coastlines that remain after mangrove clearing are more vulnerable to erosion, more exposed to storm damage, and less productive as nursery habitat for the fish species that feed millions of people across the tropical world. Fact 58, the lost glaciers, mountains losing their ice. On the high peaks and in the polar regions of the world, glaciers and ice sheets have been a defining feature of Earth's landscape for the past 2.6 million years. The great rivers of ice that carved the valleys, deposited the moraines, fed the rivers, and shaped the water supplies of hundreds of millions of people across every inhabited continent. But the glaciers of the world are retreating, and many are disappearing entirely, the visible, dramatic, and already partly completed consequence of human-caused climate change, writing itself in the shrinking ice on mountains that have been ice-covered since before our species existed. The loss of mountain glaciers is not merely an aesthetic tragedy. Glaciers serve as natural water towers, storing precipitation that falls as snow in winter, and releasing it as meltwater during the dry summer months, sustaining rivers during the season when they are needed most. The great rivers of Asia, the Ganges, the Brahmaputra, the Yangtze, the Yellow River, the Mekong, are fed partly by glacial meltwater from the Himalayan ice fields. As glaciers shrink, this meltwater contribution will first increase as the ice melts faster, then decline as the glaciers become too small to provide significant seasonal release. The Glacier National Park in the United States, established in 1910 and named for the magnificent glaciers that then occupied its mountain valleys, contained approximately 150 glaciers in 1910. Today, fewer than 30 remain, and the trend of shrinkage shows no sign of reversing. At current rates, the park's glaciers are projected to disappear entirely within decades. Similar losses are being recorded across the Alps, the Andes, the Rockies, the Caucasus, and the mountains of tropical Africa and equatorial Asia. The glaciers of Kilimanjaro, which have existed for at least 11,000 years, may be gone within a generation. The disappearing glaciers also carry with them thousands of years of climate history recorded in their ice, the air bubbles, the dust layers, the chemical isotopes that have allowed scientists to reconstruct past atmospheric composition, past temperatures, and past volcanic events. As the glaciers melt, this irreplaceable archive of Earth's climatic history is lost, not just physically but informationally. Billions of years of geological memory dissolved into the ocean, unread. Fact 59, the lost sounds of the natural world, a silence spreading across the Earth. In the 1960s, a soundscape ecologist named Bernie Krause began recording the natural soundscapes of wild places, the dawn choruses of birds in temperate forests, the frog calls of tropical wetlands, the wind through ancient grasses, the whale songs of the open ocean. Over more than 5 decades, Krause accumulated one of the largest archives of natural sound recordings in the world, recording in thousands of habitats across 6 continents. And over those 5 decades, he documented something both scientifically significant and profoundly moving. The sounds of the natural world are disappearing. More than half of the wild places he has recorded no longer exist or have been so degraded that they no longer produce the rich, layered soundscapes he originally captured. Natural soundscapes are not merely pleasant background noise. They are functioning ecological signals, the acoustic environment in which animal communication, mate finding, predator detection, and territorial behavior all take place. In a healthy ecosystem, sound is organized into a complex, structured acoustic environment. Different species occupy different acoustic niches, different frequency bands, different times of day, in a way that minimizes acoustic competition. This structured soundscape reflects the health and diversity of the ecosystem that produces it. When species disappear, the acoustic niche they occupied goes silent, and the structure of the soundscape deteriorates. The insect apocalypse, the dramatic global decline in insect populations documented across Europe, North America, and other regions, has had particularly profound acoustic consequences. Insects are the dominant sound producers of many ecosystems, from the deafening summer choruses of crickets and cicadas in temperate forests to the extraordinary complexity of tropical insect soundscapes. As insect populations decline, these soundscapes have become quieter, simpler, and less seasonally organized. The summers of the 21st century are measurably quieter than those of the mid-20th century in many parts of the world. The silence spreading across the natural world is one of the most underreported dimensions of the global biodiversity crisis. Unlike the visible extinction of large animals whose images drive conservation campaigns, the acoustic disappearance of insects, frogs, and birds is experienced as a kind of ambient impoverishment, a background fading noticed only when you know what you are no longer hearing. It is the sound of a world becoming smaller slowly in the background while the world sleeps. Fact 60, the great dying of the oceans, coral bleaching, and what comes after. The world's coral reefs, those extraordinary underwater ecosystems covering less than 1% of the ocean floor, but harboring approximately 25% of all marine species, are experiencing a crisis without precedent in the history of the modern ocean. Mass coral bleaching events caused by ocean temperatures rising above the threshold that reef-building corals can tolerate have become larger, more frequent, and more severe over the past 4 decades, transforming the ecology of reefs from the Caribbean to the Red Sea to the Great Barrier Reef. What is happening to the world's coral reefs is not a distant future threat. It is occurring right now, in real time. Coral bleaching occurs when seawater temperatures rise above a critical threshold, typically just 1 to 2 degrees Celsius above the maximum monthly average, and the corals expel the symbiotic algae called zooxanthellae that live within their tissues. These algae provide the coral with up to 90% of its energy through photosynthesis, and also give coral its characteristic color. Without them, the coral appears ghostly white, bleached, and if temperatures remain elevated for too long, the coral dies. The Great Barrier Reef experienced unprecedented mass bleaching events in 2016, 2017, 2020, 2022, and again subsequently, a frequency that gives corals insufficient time between events to recover. The ecological consequences of widespread coral death extend far beyond the corals themselves. As corals die and their calcium carbonate skeletons erode, the three-dimensional complexity of the reef, the intricate architecture of nooks, crannies, and overhangs that provides habitat for thousands of species, is lost. The hundreds of millions of people who depend on reefs for food, income from fishing and tourism, and coastal protection from waves and storms face consequences that are simultaneously ecological and deeply human. Climate projections suggest that at 1.5 degrees Celsius of global warming above pre-industrial levels, approximately 70 to 90% of the world's coral reefs will be severely degraded. At 2 degrees Celsius, more than 99% will be functionally gone. These are not geological timescales, they are projections for the next few decades. The vanishing of the world's coral reefs would be the most significant loss of marine biodiversity since the Permian mass extinction, occurring within a single human lifetime. Fact 61, the lost megafauna of Africa, the continent that almost kept its giants. Africa is famous today for its large animals, the elephants, rhinoceroses, hippopotamuses, giraffes, lions, leopards, cheetahs, and the vast herds of wildebeest and zebra and antelope. This diversity of large mammals is extraordinary by the standards of any other continent, leading many to assume that Africa's wildlife represents something close to a natural baseline, the world as it was before human influence became dominant. But this assumption is wrong. Africa's current wildlife is the survivor of a much richer megafauna assemblage that existed until relatively recently, and even Africa has lost many of its largest animals, simply more gradually and somewhat less completely than every other continent. The Africa of 3 million years ago was home to extraordinary large animals now entirely gone. There were calicotheres, large horse-like animals with clawed feet that browsed on high branches. There were civathas, giraffes with massive antlers, larger than any modern giraffe. There was Dinotherium, a creature standing 4 meters at the shoulder, larger than any modern elephant with downward curving tusks attached to its lower jaw. There were saber-toothed cats, giant hyenas, and enormous baboons. The Africa of the deep past was a land of megafauna richness that makes even modern Africa seem relatively impoverished. More recently, Africa has also lost species that survived into historical times. The bluebuck, a large antelope endemic to the southwestern Cape of South Africa, was hunted to extinction by European settlers between 1700 and 1800. The quagga, a partially striped relative of the plains zebra, was exterminated from the wild by the 1870s. Several distinct regional subspecies of African megafauna were eliminated by European hunting pressure in the 18th and 19th centuries. North Africa, which in Roman times supported elephant populations that provided animals for gladiatorial spectacles, is now entirely devoid of elephants. The reason Africa retained more of its megafauna than any other continent is likely that the evolution of effective anti-predator behavior occurred in African animals in the presence of human hunters, giving them time to develop appropriate behavioral responses. But Africa's wildlife is not immune to modern pressures. Poaching, habitat loss, and human-wildlife conflict continue to reduce Africa's remaining megafauna. The Africa of today is not the baseline. It is a diminished world, still extraordinary by global standards, but considerably poorer than the Africa that once existed. Fact 62, the lost forests of the Pacific, islands stripped to the rock. Across the islands of the Pacific Ocean, from Hawaii in the north to New Zealand in the south, from Easter Island in the east to the Marianas in the west, there once grew extraordinary forests of extraordinary diversity, evolved over millions of years of island isolation into some of the most biologically distinctive ecosystems on Earth. Each island archipelago had its own unique assemblage of plants and animals, the products of evolutionary processes operating in isolation on tiny fragments of land surrounded by thousands of kilometers of open ocean. These island forests are among the most biologically vulnerable ecosystems on Earth, and their story is largely a story of destruction, rapid, thorough, and in many cases essentially complete. Hawaii offers perhaps the most striking example of Pacific Island ecological collapse. Before Polynesian arrival approximately 1,000 to 1,500 years ago, the Hawaiian Islands supported approximately 50 to 60 species of land birds found nowhere else, honeycreepers, flightless geese, ibises, and rails that had evolved in the complete absence of mammalian predators. With Polynesian arrival came rats, dogs, pigs, and extensive burning of lowland forests. Approximately half of Hawaii's native bird species went extinct before European contact. European settlement then brought additional predators, diseases, and the conversion of remaining native forests to plantations and ranches. Easter Island, Rapa Nui, is perhaps the most famous example of Pacific Island deforestation. When Polynesian settlers arrived approximately 1,200 years ago, the island was covered in a diverse subtropical forest dominated by a now extinct palm species. The settlers cleared the forest for agriculture, used the timber for canoes and for transporting the famous stone moai statues, and progressively removed the tree cover that had protected the island's thin volcanic soils from erosion. By the time European explorers arrived in 1722, the island was almost entirely treeless, a grassland landscape of eroded gullies and the enigmatic stone statues that have fascinated the world ever since. The lesson of the Pacific Island forests is the lesson of vulnerability, of what happens when biological communities that evolved in isolation from mammalian predators suddenly encounter both humans and their accompanying animals simultaneously. The island forests of the Pacific are among the most thoroughly transformed ecosystems in the world, their original ecology surviving only in the most remote areas and in the fossil and subfossil record that documents what was lost. Fact 63. The lost peat bogs, carbon archives being burned away. Across the cool, wet landscapes of northwestern Europe, across the uplands of Scotland and Ireland, the lowland mires of the Netherlands and Germany, the vast boreal bogs of Scandinavia and Russia, and the tropical peatlands of Southeast Asia, there accumulate some of the Earth's most extraordinary ecosystems. Peat bogs, waterlogged landscapes where the rate of plant growth exceeds the rate of decomposition, causing organic material to accumulate year upon year, century upon century, into deep deposits of partially decomposed plant matter that can reach 10 meters in depth and represent thousands of years of biological accumulation. Peat bogs are living archives of climate and ecological history, and they are disappearing. The ecological uniqueness of peat bogs is remarkable. Because they are waterlogged and oxygen depleted, they preserve organic material, including pollen, plant remains, insects, and even the bodies of humans who fell into them thousands of years ago, in extraordinary detail. The bog bodies of Northern Europe, preserved human remains found in peat bogs across Ireland, Britain, Denmark, Germany, and the Netherlands, have revealed extraordinary details about Iron Age and Bronze Age life, their skin, hair, clothing, stomach contents, and even the circumstances of their deaths preserved for 2,000 to 3,000 years by the anaerobic, acidic conditions of the bog. Peat bogs are among the most important carbon stores on Earth. Though they cover only about 3% of the Earth's land surface, they contain approximately twice as much carbon as all the world's forests combined, a staggering concentration of stored carbon accumulated over thousands of years. When peat bogs are drained for agriculture, harvested for horticultural peat, or degraded by pollution, this stored carbon is released into the atmosphere as carbon dioxide and methane, contributing significantly to climate change. The world's peat bogs have been degraded or destroyed at dramatic rates. In the United Kingdom, approximately 80% of lowland raised bogs have been destroyed or severely damaged. In Southeast Asia, the vast tropical peatlands of Borneo, Sumatra, and Peninsular Malaysia have been extensively drained and converted to oil palm plantations. And when the drained peat dries out and catches fire, the resulting conflagrations release enormous quantities of carbon that took thousands of years to accumulate. Fact 64. The lost sharks, apex predators of a diminished ocean. Sharks have patrolled the world's oceans for approximately 450 million years, longer than trees have existed on land, longer than insects have flown through the air, longer than the dinosaurs ruled the Earth. They survived all 5 of the major mass extinctions that have punctuated the history of complex life, adapted and diversified through the warmest and coldest periods in Earth's Phanerozoic history, and arrived in the modern ocean as one of the most ecologically important and evolutionarily successful groups of animals that has ever existed. And then, in the span of a few decades of industrial fishing, they were reduced to a fraction of their former abundance across most of the world's ocean. The ecological role of sharks in ocean ecosystems is profound and poorly understood in its full complexity. As apex and mesopredators, sharks regulate the populations of the species below them in the food web, controlling the abundance of rays, large fish, and other predators, whose own prey populations would explode without the regulating pressure of shark predation. The removal of sharks from marine ecosystems has been shown, in multiple documented cases, to trigger dramatic ecological cascades. In the northwestern Atlantic, the collapse of shark populations contributed to an explosion in the populations of Kaunos rays, which in turn devastated scallop populations and collapsed commercially important shellfish fisheries. The global shark population has been reduced by an estimated 71% since 1970, a collapse driven by targeted shark fishing, the shark fin trade, and bycatch in industrial fishing operations. The most heavily affected species include oceanic sharks and rays, the great hammerhead, the scalloped hammerhead, the oceanic whitetip, the shortfin marco, all endangered or critically endangered. The oceanic whitetip, once described by Jacques Cousteau as probably the most numerous large animal on Earth, has been reduced by approximately 95% across the Atlantic Ocean. The loss of sharks from the world's oceans is a loss whose full consequences we are only beginning to understand. Ocean food webs built over millions of years with sharks as integral components are now operating without them, and the ecological consequences, the cascading effects on fish populations, on marine mammal populations, on the structure of reef communities, are complex, ongoing, and in many cases irreversible. The sharks are still there, but the ocean they patrol is not the ocean it was, and neither are they. Fact 65: the lost savannas of Asia, when elephants roamed from Turkey to Java. Today, Asian elephants survive in isolated, fragmented populations across a narrow band of South and Southeast Asia, in the forests of India, Sri Lanka, Thailand, Sumatra, Borneo, and a few other areas. Their range represents a tiny fraction of what it once was. In the geological past, and in some cases within historical memory, elephants ranged across an enormous expanse of Asia, from the eastern Mediterranean coast through the Middle East, across Central Asia, through China, and throughout Southeast Asia to the islands of Indonesia. The retreat of the elephant from most of this vast range is one of the most dramatic range contractions in the history of any large mammal. In the early Holocene, just 10,000 years ago, the straight-tusked elephant ranged across the Middle East, Central Asia, and into China. Chinese oracle bones from the Shang dynasty period, approximately 3,200 years ago, record elephant hunts in what is now the Yellow River Valley of central China, a region now densely populated agricultural land where elephants have been absent for millennia. Wild elephants survived in Syria until approximately 700 BCE, when they were extirpated by Assyrian kings who hunted them for ivory and sport. In North Africa, a now extinct forest elephant persisted until approximately the 1st or 2nd century CE, before being hunted to extinction for the Roman games. The contraction of the elephants' range across Asia correlates closely with the expansion of human populations and agricultural land use. As forests were cleared and grasslands converted to farmland, the large areas of natural habitat that elephants require shrank and fragmented, reducing their populations and eventually eliminating them from region after region. In some areas, elephants were actively hunted for ivory, for meat, or as competitors for agricultural land. In others, they simply ran out of habitat as human populations expanded into every remaining corner of their range. The Asian elephants that survive today are the remnants of what was once a continent-spanning megafaunal presence. Their current range, fragmented, surrounded by human-dominated landscapes, increasingly confined to protected areas, is a ghost of the savanna and forest world they once inhabited across one of the Earth's largest and most diverse landmasses. The sounds of elephants once echoed from the Levant to the Pacific. Today they echo in a handful of reserves. Fact 66: the lost rivers of the American West, water diverted to dust. The rivers of the American West, the Colorado, the Rio Grande, the Sacramento, the Snake, the Green, are among the most heavily managed, diverted, and impounded river systems in the world. Their waters are allocated, metered, argued over in courts, and divided among users through systems of water rights so complex that thousands of lawyers and hydrologists spend their careers navigating them. But these rivers were not always the managed, dammed, and diminished systems they are today. They were once wild, seasonal, flood-pulsed rivers that reached the sea, supporting extraordinary biological communities along their entire lengths. The Colorado River, which drains approximately 650,000 square kilometers of the American Southwest, flowing from the Rocky Mountains through the Grand Canyon to the Gulf of California, no longer reaches the sea. The river's water is fully allocated among 7 U.S. states and Mexico, and in most years the river runs dry long before it reaches its historic delta. The Colorado River Delta, once an extraordinary wetland ecosystem covering approximately 8,000 square kilometers, a maze of channels and cottonwood forests supporting jaguars, river otters, and vast populations of migratory birds, has been reduced to a dry salt flat, one of the most dramatic ecological collapses caused by water diversion in the world. The dams and diversions that transformed the American West's rivers were built in the 20th century with a confidence in human mastery of nature that has since been tempered by experience. The Columbia River's salmon runs, once so dense that travelers described the river as nearly solid fish during spawning, were devastated by hydroelectric dams that blocked the salmon's upstream migration routes. Native fish species evolved over millions of years in the specific hydrological conditions of these rivers are among the most endangered vertebrates in North America. The lost rivers of the American West are not entirely gone, water still flows through their channels, and some river restoration projects have demonstrated that rivers can recover significant ecological function within years of dam removal. But the biological communities that evolved over millions of years in these specific river systems, the endemic fish, the riparian plants, the insects, the amphibians, cannot be fully recovered once they are gone. Fact 67. The lost insects, the invisible catastrophe. The disappearance of insects from the world is, in many ways, the least visible and least reported of the major ecological crises currently unfolding on Earth, and arguably the most consequential. Insects are the ecological foundation of terrestrial and freshwater ecosystems. They pollinate the majority of the world's flowering plants. They are the primary food source for most of the world's freshwater fish, and a large proportion of its birds, amphibians, and small mammals. They decompose organic matter and cycle nutrients. The loss of insects is not merely the loss of some inconvenient bugs. It is the dismantling of the ecological infrastructure on which almost everything else depends. The evidence for a dramatic global decline in insect populations has accumulated rapidly in recent years, particularly following a landmark 2017 study from Germany that found a 75% decline in total flying insect biomass over 27 years across protected natural areas. Subsequent studies in the United Kingdom, Puerto Rico, China, and elsewhere have found similar patterns of dramatic decline in total abundance, in species richness, and in the ecological function that insects provide. The causes are multiple and interacting: agricultural pesticides, particularly neonicotinoids, habitat loss and fragmentation, light pollution, which disrupts insect navigation and mating behavior, and climate change, which alters the timing of insect life cycles. The ecological consequences of insect decline are cascading through food webs in measurable ways. Farmland bird populations across Europe have declined by approximately 55% since 1980, driven largely by the collapse of the insect populations they depend on. Freshwater fish populations have declined alongside the aquatic insect larvae, mayflies, stoneflies, caddisflies, that form the base of freshwater food webs. The wildflower meadows of Europe, themselves already rare and fragmented, are less productive as pollinators decline, their reproduction limited by the absence of the insect communities that evolved alongside them. The insect catastrophe is happening largely below the threshold of everyday human perception. We do not mourn individual beetles or moths as we mourn individual tigers or elephants. The windshields of cars that were once covered in insect remains after a summer drive are now clean, a change so gradual that it has been normalized, integrated into our sense of what summer is like. But the clean windshield is a sign of a world that has lost something enormous, something foundational, something that cannot easily be replaced. Fact 68. The lost migrations, when the animals still moved across the earth. One of the most spectacular phenomena in the natural world is the large-scale migration of animals across vast distances: the wildebeest migration of the Serengeti, the monarch butterfly migration from Canada to Mexico, the annual salmon runs of the Pacific Northwest, the twice-yearly migrations of shorebirds between Arctic breeding grounds and tropical wintering areas. These migrations are among the most visible expressions of the ecological richness of a connected planet. And they are in decline, not because the habitats at either end are necessarily gone, but because the corridors between them have been transformed by human land use. In the 19th century, North America witnessed some of the largest animal migrations in the history of the continent. Beyond the famous bison migrations of the Great Plains, the rivers of the eastern United States ran silver with American shad during annual spawning runs, so dense that observers described the fish pushing against each other in crowded rivers. The skies of the Midwest filled each spring and autumn with the migration of passenger pigeons, in numbers observers compared to rivers of birds flowing horizon to horizon. The coastal wetlands of the Atlantic Flyway teemed with shorebirds in numbers that modern observers of those same depleted wetlands can barely imagine. Many migrations have been physically severed by the infrastructure of modern civilization, by highways, fences, dams, and urban areas that block paths that migratory animals have followed for thousands or millions of years. The pronghorn antelope of the American West follows migratory routes established during the Pleistocene, when the landscape they traversed was open grassland. Today, those routes are interrupted by highways, subdivisions, and ranch fences, forcing the animals through bottlenecks so narrow that a single fence can stop a migration that has persisted for tens of thousands of years. The loss of migration is a loss not only of the animals themselves, but of the ecological processes their movement sustained. Migrating animals move nutrients, seeds, and energy across landscapes, connecting distant ecosystems in ways that maintain the productivity of both. The salmon that swam upstream to spawn carried marine-derived nutrients deep into the forests of the Pacific Northwest, fertilizing the trees with the bodies of fish that had grown fat in the ocean. Without the salmon, the forests are different. Without the migrations, the landscapes through which the animals once moved are diminished in ways that are difficult to quantify but easy to perceive. Fact 69, the lost tundra, permafrost on the edge of thaw. Beneath approximately 25% of the northern hemisphere's land surface, beneath the tundra of Siberia, Alaska, Canada, and the Tibetan Plateau, there lies a vast reservoir of frozen ground known as permafrost, ground that has remained continuously frozen for anywhere from hundreds to hundreds of thousands of years. This frozen ground contains an enormous quantity of organic carbon preserved from decomposition by the cold. Conservative estimates suggest that the permafrost region contains approximately 1.5 trillion tons of carbon, roughly twice the amount currently present in the atmosphere as carbon dioxide. And as the Arctic warms at a rate approximately 2 to 4 times faster than the global average, this frozen carbon is beginning to thaw. The tundra ecosystems that sit atop the permafrost are themselves among the most dramatic indicators of Arctic warming. The treeline, the boundary between the boreal forest to the south and the treeless tundra to the north, is moving northward as temperatures rise, with shrubs and trees advancing into areas that were open tundra a century ago. This process, known as shrubification, is changing the character of the tundra in ways that affect its energy balance and its role in the global carbon cycle. Darker shrub vegetation absorbs more solar energy than the reflective snow and sparse tundra plants it replaces, accelerating warming in a self-reinforcing feedback loop. The permafrost thaw is releasing methane, a greenhouse gas approximately 80 times more powerful than carbon dioxide over a 20-year timescale, from the anaerobic decomposition of organic material. In some areas, the thawing of ice-rich permafrost is causing dramatic physical changes to the landscape, a process called thermocast, in which the ground collapses as the ice within it melts, creating lakes, sinkholes, and landslides in what was previously stable frozen terrain. Entire hillsides are slumping. Coastlines built on permafrost are collapsing into the sea. Infrastructure across the Arctic is being undermined as the ground beneath it thaws. The tundra ecosystem, the mosses, the lichens, the sedges, the nesting grounds of millions of Arctic breeding shorebirds, the calving grounds of caribou and reindeer, is not disappearing overnight, but it is changing faster than at any time in the past 10,000 years, driven by temperatures that are rising beyond the experience of the current ecosystem. The tundra that will exist at the end of this century will be a different world from the tundra that exists today. Fact 70, the lost night sky light that erased the stars. For millions of years, from the first hominid who looked up from the African savanna to the last generation before electricity, the night sky was one of the most constant and spectacular features of human experience. The Milky Way arched overhead, a river of light containing 100 billion stars, visible to the naked eye as a luminous band from horizon to horizon on any clear, moonless night. Ancient peoples navigated by the stars, built their calendars around them, wove them into their mythologies, and experienced the universe through them. And then, in approximately 150 years, barely 2 human lifetimes, the night sky was erased. Light pollution, the brightening of the night sky by artificial light scattered from human settlements, now affects the majority of the world's human population. A 2016 study found that approximately 80% of the world's population lives under light-polluted skies, including 99% of the population of Europe and the United States. More than 1/3 of humanity can no longer see the Milky Way from where they live. The night sky visible from a major city today contains perhaps a few hundred stars, compared to the several thousand visible to the unaided eye under truly dark conditions. The universe visible to every human being for most of history is now inaccessible to most people alive. The ecological consequences of artificial light at night extend far beyond human experience. Light pollution disrupts the circadian rhythms of insects, birds, sea turtles, and countless other animals that have evolved to navigate, feed, and mate using natural light cycles. Migratory birds, which navigate partly by the stars, are disoriented by urban light pollution, colliding with illuminated buildings during migration. Sea turtle hatchlings, programmed to move toward the brightest horizon, which in natural conditions is the sea, are fatally disoriented by coastal lighting and march inland instead of toward the ocean. The dark sky is a vanished world that could, more than almost any other in this journey, be partially recovered, not through millions of years of ecological succession, but through the deliberate choice to shield outdoor lights, reduce unnecessary illumination, and restore the darkness that has been the nightly backdrop of life on Earth for billions of years. The stars are still there. The darkness can be returned. But in most of the world, the people alive today have never seen the sky that every human being saw every night for all of human history before them. Fact 71. The lost forests of Central Africa, the Congo Basin under pressure. The Congo Basin rainforest, the second largest tropical rainforest on Earth after the Amazon, covering approximately 3.3 million square kilometers across the Democratic Republic of Congo, Cameroon, Gabon, the Central African Republic, and Equatorial Guinea, is one of the most carbon-dense and biologically rich ecosystems on the planet. It is home to forest elephants, western lowland gorillas, chimpanzees, bonobos, okapis, and hundreds of species found nowhere else. It is also one of the world's most important carbon sinks, storing an estimated 30 billion tons of carbon in its trees and soils. And though it remains largely intact compared to other major tropical forests, it is under growing pressure. Logging, both legal and illegal, is expanding deeper into previously inaccessible forest as new roads are built. Agricultural expansion is clearing forest edges for subsistence farming and increasingly for commercial agriculture. Charcoal production, which provides cooking fuel for the rapidly growing urban populations of Central Africa, is consuming enormous quantities of forest biomass. And the bushmeat trade is depleting the animal populations within the forest, even in areas where the trees themselves remain standing. The Congo forest is particularly important because it contains the world's largest tropical peatland, discovered in 2017 in the Cuvette Centrale region of the Republic of Congo and Democratic Republic of Congo. This peatland, covering approximately 145,500 square kilometers, an area larger than England, stores approximately 30 billion tons of carbon in its waterlogged peat deposits, equivalent to approximately 3 years of global fossil fuel emissions. The discovery dramatically increased estimates of the Congo Basin's total carbon storage and highlighted the extraordinary global importance of keeping this ecosystem intact. The Congo forest's fate will be determined largely by the economic development choices of some of the world's poorest countries, facing pressure to exploit their natural resources to lift their populations out of poverty. The global community that depends on the Congo forest for climate stabilization has a responsibility to support alternative development pathways that allow the forest and its peoples to thrive together, a responsibility that has historically been inadequately honored, and that grows more urgent with every hectare cleared. Fact 72. The lost megafauna of the Caribbean, islands before Columbus. When Christopher Columbus arrived in the Caribbean in 1492, he encountered a landscape that was already significantly different from what it had been before human arrival in the region. The Caribbean islands had been settled by Amerindian peoples, the Taino and their predecessors, beginning approximately 7,000 to 8,000 years ago, and in the centuries before European contact, these settlements had already caused significant changes to the ecology of the islands. But the changes wrought by European colonization in the centuries following 1492 were of an entirely different order of magnitude, transforming the Caribbean from one of the world's most biologically diverse island regions into one of its most impoverished. Before human settlement, the Caribbean islands supported an extraordinary diversity of large animals. There were giant ground sloths, smaller than their South American relatives but still substantial animals, weighing up to 200 kilograms, that had colonized the islands from the South American mainland during periods of lower sea level. There were giant rodents, hatillas and their relatives, that had evolved into the largest land mammals on many islands in the absence of large predators. There were diverse species of large land tortoises. There were native land birds including large flightless species and numerous species of rails, owls, and raptors. The arrival of Amerindian peoples initiated the first wave of extinctions. The giant ground sloths were eliminated from most Caribbean islands within a few thousand years of human arrival, along with many of the larger native mammals. But the scale of ecological transformation accelerated dramatically with European colonization. The introduction of rats, cats, pigs, goats, and mongooses to islands that had evolved without mammalian predators eliminated the ground-nesting birds that had survived earlier human impact. The clearing of forests for sugar plantations removed the habitat of countless species. The slave trade and plantation agriculture transformed the landscape of virtually every island in the region. Today, the Caribbean has one of the highest rates of species extinction of any region on Earth, and many of its remaining endemic species, the Cuban crocodile, the Puerto Rican parrot, the Jamaican iguana, are critically endangered. The rich, complex ecological world that existed before human settlement is known largely from the bones preserved in cave deposits and coastal sediments, the fossils of creatures that lived and died on islands whose current inhabitants have no cultural memory of them. Fact 73. The Lost Boreal Forests, the world's largest biome under threat. The boreal forest, known in Russian as the taiga, is the world's largest terrestrial biome, a vast belt of coniferous forest stretching across the northern latitudes of Russia, Canada, Alaska, and Scandinavia, covering approximately 11 million square kilometers, roughly 30% of the world's forest cover. This immense forest is not the lush, species-rich ecosystem of the tropical rainforest. It is dominated by relatively few tree species, primarily spruce, fir, pine, and larch, growing in conditions of extreme cold, deep snow, and acidic, nutrient-poor soils. But what the boreal forest lacks in species richness it more than makes up for in scale, in carbon storage, and in the ecological services it provides to the entire northern hemisphere. The boreal forest stores an estimated 270 to 370 billion tons of carbon in its trees, soil, and underlying peat, making it, alongside the permafrost beneath it, one of the most important carbon stores on Earth. Much of this carbon is stored not in the trees themselves, but in the thick organic soils and peat deposits that have accumulated over thousands of years under the cold, wet conditions that characterize much of the boreal zone. These soils are extraordinarily carbon-dense because the cold conditions slow decomposition, allowing organic material to accumulate faster than it breaks down. The boreal forest is changing rapidly in response to climate change, which is affecting the high latitudes more severely than anywhere else on Earth. Rising temperatures are increasing the frequency, severity, and extent of forest fires across the boreal zone, fires that release enormous quantities of carbon from both the burning trees and the underlying peat. In recent years, fires have burned millions of hectares of boreal forest in Russia, Canada, and Siberia, some of them described as the largest fires in recorded history. The warmer, drier conditions that climate change is producing across much of the boreal zone are also allowing insect pests, particularly bark beetles, to expand their range and devastate forest stands. The boreal forest is also under direct human pressure from logging, mining, and energy development. Canada's boreal forest in particular has been heavily exploited for timber, pulp, and oil sands development, with significant areas of intact forest fragmented and degraded. The loss of the boreal forest, the world's largest single ecosystem, would represent a climate catastrophe of almost incalculable proportions, releasing stored carbon that has been accumulating since the end of the last ice age. Fact 74. The lost megafauna of Southeast Asia, forests emptied of their giants. The tropical forests of Southeast Asia, the rainforests of Borneo, Sumatra, Peninsula Malaysia, and the islands of the Philippines and Indonesia, are among the most biodiverse and ecologically complex ecosystems on Earth. They are home to orangutans, proboscis monkeys, pygmy elephants, Sumatran rhinoceroses, clouded leopards, sun bears, and hundreds of species found nowhere else. They are also among the most threatened tropical forests on Earth, cleared at staggering rates for oil palm plantations, timber production, and agricultural expansion in one of the most economically dynamic regions of the world. The Sumatran rhinoceros, the smallest and most ancient of the surviving rhinoceros species, a direct descendant of the woolly rhinoceros that once roamed Ice Age Europe and Asia, is one of the most critically endangered large mammals on Earth, with a wild population estimated at fewer than 80 individuals confined to fragments of forest in Sumatra and Borneo. The Sumatran rhinoceros is a living fossil. Its basic body plan has remained largely unchanged for millions of years, and its extinction, which now seems almost inevitable within the next generation, will represent the loss of an entire evolutionary lineage with no living relatives. The Javan rhinoceros, once found from India to Indonesia, now survives as a single population of approximately 70 individuals in one national park in Western Java. The Bornean and Sumatran orangutans, our closest relatives after chimpanzees and bonobos, have lost approximately 50 to 80% of their forest habitat in the past 60 years to logging and oil palm development. Both species are critically endangered. The isolation of orangutan populations in forest fragments, surrounded by oil palm plantations, has created a landscape of genetic islands in which inbreeding and reduced genetic diversity are compounding the effects of habitat loss. The forests of Southeast Asia are being emptied of their large animals, even in areas where the forest itself remains standing, a process called defaunation, in which hunting pressure removes the large vertebrates from forest while leaving the trees intact. Empty forests that look healthy from above, but are biologically depleted of the large animals that maintain their ecological function, cover vast areas of Southeast Asia, a silent crisis unfolding beneath the green canopy. Fact 75. The lost salmon runs, rivers without their silver floods. Few events in the natural world are more spectacular than the Pacific salmon run, the annual migration of millions of adult salmon from the ocean into the rivers and streams of the Pacific Northwest, swimming upstream against the current for hundreds of kilometers to reach the gravel beds where they were born, spawning and dying, their bodies fertilizing the forest with marine nutrients that feed trees, bears, eagles, and dozens of other species in an ecological cascade, connecting the ocean to the depths of the temperate forest. For thousands of years, the Pacific salmon runs sustained the indigenous cultures of the Pacific Northwest with a richness that allowed the development of some of the most complex non-agricultural civilizations in human history. The Pacific salmon runs have been declining since European settlement in the 19th century, driven by a combination of factors progressively degrading the rivers, streams, and estuary habitats that salmon depend on. Dams have blocked salmon migration routes on virtually every major river in the Pacific Northwest. The Columbia River Basin alone contains more than 400 dams, blocking salmon from reaching the vast majority of their historic spawning habitat. Logging has degraded the stream habitats that salmon require for spawning. Agricultural runoff has degraded water quality. Urban development has paved over floodplains and disconnected rivers from the wetland habitats that juvenile salmon depend on. In California, where all 5 Pacific salmon species once ran in rivers throughout the Central Valley, populations have declined by approximately 90% from historic levels. Several distinct salmon populations have been listed as threatened or endangered under the Endangered Species Act, and some runs that once supported important commercial fisheries have been reduced to a few hundred individuals. The rivers of California's Central Valley, once running silver in autumn with the bodies of returning salmon, are largely empty of them now. The loss of the salmon runs cascades through entire ecosystems. Bears that once fattened on salmon before hibernation are less well nourished. Eagles and herons that concentrated at spawning streams have dispersed. The forests along salmon streams, fertilized for thousands of years by the marine nitrogen carried in salmon bodies, are growing more slowly. The ecological relationships built over millions of years between the Pacific salmon and the ecosystems they inhabited are being dismantled by dams and degraded rivers. Fact 76. The lost megafauna of North Africa, when the Sahara had lions. Today, the Sahara Desert is one of the harshest and most inhospitable environments on Earth, a landscape of sand and rock and blazing heat stretching thousands of kilometers across northern Africa, supporting almost no large vertebrate life. But we have already explored how the Sahara was once green, how the African humid period, approximately 11,000 to 5,000 years ago, transformed the desert into a landscape of lakes, rivers, and forests. What we have not yet explored is that even after the Green Sahara ended, Northern Africa supported a megafauna of extraordinary richness that persisted until recent centuries, and that the loss of this megafauna is one of the least known ecological tragedies of the modern era. The rock art of the Sahara, painted and carved on the walls of caves and rock shelters across the Central Sahara, depicts animals that have long since vanished from the region. There are paintings of elephants, giraffes, hippopotamuses, crocodiles, aurochs, and various antelope species, all animals that now survive, if at all, only south of the Sahara in sub-Saharan Africa. The rock art documents a landscape of extraordinary biological richness in what is now harsh desert, and it tells us that the people of the Green Sahara lived alongside megafauna that modern North Africans know only as distant sub-Saharan species. Even after the Green Sahara ended and the desert returned, substantial wildlife populations persisted in the mountain ranges of the Central Sahara, the Ahaga, the Taibesti, the Air, where springs and seasonal vegetation supported relic populations of large animals. The Atlas lion, the largest known subspecies of lion, immortalized in Roman spectacles and the pages of ancient writers, survived in the forests of the Atlas Mountains of northwestern Africa until the early 20th century. The last known wild Atlas lion was shot in Morocco in 1942. The Barbary leopard survived into the 1960s. North African cheetahs, now critically endangered, survive in tiny numbers in the Central Sahara. The megafauna of North Africa is largely gone, its memory preserved in cave paintings and ancient texts, and the bones buried in desert sediments. The lions of the Atlas, the elephants of the Maghreb, the hippos of the Nile Delta, all eliminated within the past few centuries by a combination of hunting, habitat loss, and the demands of the Roman entertainment industry, which consumed North African wildlife at an industrial scale for 4 centuries. Fact 77. The lost estuaries, where rivers once met the sea. Estuaries, the transitional zones where freshwater rivers meet the saltwater sea, The tidal marshes and mudflats and seagrass beds that occupy the intertidal zone between land and ocean are among the most productive and ecologically important ecosystems on Earth. They are the nurseries of the ocean, providing shelter, food, and the warm, nutrient-rich conditions that juvenile fish and invertebrates need to survive their most vulnerable life stages. They are filter systems, trapping sediment and processing nutrients before they reach the open sea. They are carbon stores, accumulating organic material at rates that rival tropical forests. And they are among the most damaged and degraded ecosystems on Earth, lost to port development, coastal urbanization, agricultural reclamation, and industrial pollution. The world's great estuaries have all been dramatically transformed from their natural states within the past 150 to 200 years. The Chesapeake Bay, once among the most productive estuaries in the world, its waters so full of oysters that early European settlers described the shellfish beds as navigation hazards, has lost approximately 99% of its historic oyster population to overharvesting, disease, and the nutrient pollution that has created vast oxygen-depleted dead zones across much of the bay's deeper waters. The Thames estuary, flowing through the heart of London, was by the mid-20th century one of the most polluted estuaries in the world, so depleted of oxygen by sewage and industrial effluent that it supported virtually no fish life for approximately 30 kilometers through the center of the city. The salmon that had once run in the Thames, so abundant in medieval London that apprentices reportedly went on strike to protest being fed salmon more than 3 days a week, had been absent from the river for more than a century. Subsequent investment in sewage treatment has brought the Thames back to a point where salmon have returned, a genuine conservation success story in a sea of bad news. Globally, estuaries have lost an estimated 50% of their salt marshes, seagrass beds, and mangrove forests in the past century. The fish and shellfish that depended on estuary habitats as nursery grounds are less abundant across the world's coastal fisheries as a direct consequence. The ecological services that functioning estuaries provided, water filtration, storm buffering, carbon storage, and juvenile habitat, are diminished or absent from coastlines whose estuaries have been filled, dredged, or polluted beyond biological function. Fact 78: the lost Great Plains of South America, the Pampas in transformation. The Pampas, the vast temperate grasslands of Argentina, Uruguay, and southern Brazil, are one of the world's great grassland ecosystems, covering approximately 750,000 square kilometers of flat, fertile, windswept plain stretching from the Atlantic coast to the foothills of the Andes. The Pampas are defined by their grasses, a complex community of native grass species that evolved over millions of years with the grazing animals of the South American savanna, and by their extraordinary fertility, which has made Argentina one of the world's great agricultural nations. But the Pampas that exists today is a shadow of what it was before European settlement, and the transformation of these grasslands is one of the most complete and least recognized ecological changes in the history of South America. Before European settlement in the 16th and 17th centuries, the Pampas supported a diverse community of large grazing animals: guanacos, rheas, pampas deer, giant anteaters, giant armadillos, and the now extinct macrauchenia and other Pleistocene survivors that had clung on after the great megafauna extinction of the end of the Ice Age. The grasslands were maintained and shaped by these grazers, by fire, and by the highly seasonal rainfall patterns of the region. The native Pampas grasses, many of them bunch grasses rather than mat-forming grasses, created a patchy, heterogeneous vegetation structure that supported diverse communities of invertebrates, birds, and reptiles. European settlement brought cattle, horses, and sheep, animals that would ultimately transform the Pampas more thoroughly than anything that had come before. Initially, vast herds of feral cattle and horses roamed the open grasslands, creating the landscape of the gauchero culture that became central to Argentine national identity. But in the 19th and 20th centuries, the open grasslands were progressively fenced, plowed, and converted to crop production, first wheat and corn, and more recently soybeans, whose cultivation has expanded dramatically across former grassland in the past few decades. Today, native grassland covers only a small fraction of the original Pampas extent. Most of the original native grass species have been replaced by introduced pasture grasses. The native wildlife, the Pampas deer, the giant anteater, the maned wolf, the giant armadillo, survive in fragmented populations in scattered protected areas. The Pampas is one of the least protected major grassland ecosystems in the world, overshadowed in conservation attention by the tropical forests to its north. Fact 79: the lost freshwater dolphins, rivers without their ancient swimmers. The world's freshwater dolphins, the river dolphins of the Amazon, the Orinoco, the Ganges, the Brahmaputra, the Yangtze, and the Indus, are among the most ancient and evolutionarily distinctive groups of cetaceans alive today, their lineages diverging from their marine relatives tens of millions of years ago as they colonized the great river systems of Asia and South America. They are also, without exception, among the most endangered cetaceans on Earth, their freshwater habitats under intense pressure from dams, pollution, fishing nets, and boat traffic in some of the most heavily populated river corridors in the world. In the Yangtze River of China, one species, the beiji, has already crossed the threshold into extinction, becoming the first cetacean driven to extinction by human activity in modern times. The beiji Lipotes vexillifer was a pale, nearly blind dolphin endemic to the Yangtze River. As China industrialized rapidly in the second half of the 20th century, the Yangtze became increasingly hostile to the beiji. Dams fragmented its habitat, fishing nets caught and drowned individuals, boat propellers injured others, and industrial pollution degraded the river's ecology. A dedicated survey of the entire Yangtze River in 2006 found no beiji, and subsequent surveys have confirmed that the species is almost certainly extinct. The beiji is gone, a species that had inhabited Chinese rivers for approximately 20 million years, eliminated in a few decades. The Amazon River dolphin, the boto, or pink river dolphin, remains relatively more abundant, but is increasingly threatened by mercury pollution from gold mining in the Amazon basin, deliberate killing by fishermen who consider it a competitor or use its body parts as bait, and the ongoing fragmentation of its river habitat by dams. The South Asian river dolphins, the Ganges river dolphin and the Indus river dolphin, are both endangered, their populations reduced by dams that block their movement between river segments and by the extraordinarily high levels of human activity in the rivers they inhabit. The loss of freshwater dolphins is not only the loss of extraordinary animals, it is the loss of indicators of river ecosystem health, whose absence signals a broader collapse of freshwater biodiversity. The rivers that once supported river dolphins are rivers in crisis, their fish populations depleted, their water quality degraded, their hydrology altered by dams, and the dolphins are merely the most visible expression of a pervasive and largely invisible freshwater ecological emergency. Fact 80: the lost grasslands of India, where tigers once hunted open land. India's popular image as a wildlife destination is dominated by its forests, the tiger reserves of central India, the elephant forests of the Western Ghats, the mangrove forests of the Sundarbans. But India was not always primarily a forest landscape. Across the subcontinent, from the Terai foothills of the Himalaya to the Deccan Plateau, there once stretched vast areas of native grassland, the Indian savanna ecosystem, sometimes called the Indian steppes or the tropical dry grasslands, which supported a remarkable community of large mammals that has been dramatically reduced, and in many cases entirely eliminated in the past 2 centuries. The Indian grassland ecosystem was historically the domain of the tiger in its hunting form, not the forest tiger of popular imagination, but a grassland predator hunting in the open habitats of tall grass savanna, taking prey including blackbuck, chinkara, nilgai, wild buffalo, and the last wild populations of the Indian cheetah. The Indian cheetah, a distinct subspecies of the cheetah, the fastest land animal on Earth, was the hunting companion of Mughal emperors who used trained cheetahs for coursing. By the early 20th century, the Indian cheetah was extinct on the subcontinent, hunted to elimination and deprived of the open grassland habitat it required. The Indian grassland ecosystem is also the last remaining habitat of the great Indian bustard, one of the heaviest flying birds in the world, once found across the grasslands of the Indian subcontinent from Rajasthan to Andhra Pradesh, now reduced to approximately 100 to 150 individuals, confined to a few fragments of native grassland in Rajasthan. The great Indian bustard is considered one of the most critically endangered birds in the world, its population declining toward extinction as its grassland habitat is converted to agriculture and solar energy installations, and as individuals collide with the power lines that cross the open landscapes they depend on. The loss of India's grasslands is also the loss of a pastoral culture, the communities of herders and nomads who managed the grasslands sustainably for centuries, moving their animals with the seasons in patterns that maintained the grassland ecology while supporting human livelihoods. The replacement of these traditional land uses with sedentary agriculture and industrial development has eliminated both the grassland ecosystem and the human culture that was adapted to it. 80 worlds now, somewhere in the forests of Central Africa, the gorillas still sleep. In the rivers of the Pacific Northwest, a few salmon still swim upstream. In the Central Sahara, the bones of lions lie buried under 1,000 years of sand. 20 worlds remain, This is explored during sleeping. Fact 81. The lost forests of Australia before the fire and the axe. Australia's forests and woodlands today present a landscape that appears ancient and unchanged. The eucalyptus forests with their peeling bark and koalas, the ancient Gondwana rainforests of Queensland, the Jarrah and Marri forests of Western Australia. But this landscape is the product of multiple waves of transformation. First by the Aboriginal peoples who managed the Australian landscape with fire for at least 65,000 years, and then by European settlers who arrived in 1788 and systematically cleared, burned, and grazed the continent's vegetation at a rate and scale that transformed it more thoroughly in 250 years than fire had done in 65,000. Before European settlement, Australia was covered by approximately 125 million hectares of forest and another 450 million hectares of woodland and shrubland, vegetation communities of extraordinary diversity, from the tropical rainforests of the northeast to the temperate rainforests of Tasmania to the vast mallee scrublands of the interior. This vegetation had co-evolved over millions of years with Australia's unique fauna, including the marsupials and monotremes that make the Australian biota so distinctive, and with the fire management practices of the Aboriginal peoples whose burning regimes maintained the mosaic of grassland, woodland and forest that characterized the pre-European landscape. Since 1788, Australia has cleared approximately 40 million hectares of native forest and woodland, an area larger than Germany, primarily for agriculture and pastoral development. Australia has driven approximately 100 species of vertebrate to extinction since European settlement, more than any other continent in the same period, and the loss of native vegetation is the primary driver of these extinctions. Australia continues to clear native vegetation at rates that draw international criticism, particularly in Queensland, where land clearing regulations have been repeatedly weakened under agricultural industry pressure. The forests of Tasmania represent some of the most ancient and intact temperate ecosystems in the southern hemisphere, containing trees over 3,000 years old and hosting the Tasmanian devil, the world's largest surviving carnivorous marsupial. These forests are also among the most carbon-dense on Earth, their giant eucalyptus trees storing more carbon per hectare than any other forest type. They remain partially protected and partially logged, their fate contested between conservation and commercial timber interests in one of the world's longest-running environmental disputes. Fact 82. The lost ocean giants, whales before the industrial slaughter. Before the era of industrial whaling, before the invention of the explosive harpoon gun in 1868, and the development of factory ships that could process entire whale carcasses at sea, the world's oceans contained whale populations of a size and abundance almost impossible to conceive from the perspective of today's ocean. The great whales, the blue whale, the fin whale, the humpback, the sperm whale, the right whale, the bowhead, patrolled the oceans in numbers that modern marine biologists estimate to have been 5 to 10 times greater than the populations that exist today, after over a century of industrial hunting that killed an estimated 3 million whales between 1900 and 1999 alone. The blue whale, the largest animal that has ever existed on Earth, reaching lengths of over 30 meters and weights approaching 200 tons, was once abundant throughout the world's oceans. Estimates of the pre-whaling blue whale population range from 200,000 to 300,000 individuals. By 1967, when commercial hunting of blue whales was finally prohibited, the global population had been reduced to approximately 400 to 1,400 individuals, a decline of 97 to 99%. Today, despite decades of protection, the global blue whale population is estimated at approximately 10,000 to 25,000 individuals, still a tiny fraction of its historic abundance. The ecological role of great whales in ocean ecosystems is profound and only recently understood. Whales are active pumps of nutrients, cycling the marine food web in ways that enhance the productivity of the entire ocean. Their feces, rich in iron and nitrogen, limiting nutrients in many ocean ecosystems, fertilize phytoplankton blooms. Their seasonal migrations move nutrients from deep, cold feeding grounds to warm, nutrient-poor surface waters. Even their deaths contribute to ocean productivity. A whale fall, the sinking of a dead whale to the seafloor, creates a unique ecosystem supporting dozens of specialist species for decades. The recovery of whale populations since the end of commercial whaling has been uneven and incomplete. The North Atlantic right whale numbers only approximately 340 to 360 individuals today, still threatened by ship strikes and entanglement in fishing gear. The Antarctic blue whale, reduced to perhaps 400 individuals at its nadir, has recovered to perhaps a few thousand, but remains far below its historic numbers. The full restoration of pre-whaling whale abundance would require centuries of protection, and the recovery of the ecological functions these animals performed in a fundamentally altered ocean. Fact 83. The lost forests of the Mediterranean, ancient landscapes deforested. The Mediterranean basin today is characterized by a landscape of rocky hillsides covered in low scrubland, olive groves, vineyards, and sun-bleached ruins. This landscape is ancient and beautiful, and it has shaped the civilizations that grew within it so profoundly that it is difficult to imagine it being any other way. But the rocky, scrub-covered hills of Greece, Italy, Turkey, Lebanon, and North Africa are not the natural landscape of the Mediterranean. They are the aftermath of one of the longest and most thorough deforestation processes in human history, extending over 5,000 to 8,000 years, and involving the removal of forest from virtually every accessible slope in one of the world's most densely populated ancient regions. Before the rise of the Mediterranean civilizations, before the Greeks, the Romans, the Phoenicians, and their predecessors, the Mediterranean basin was significantly more forested. The hillsides of Greece and Turkey were covered in oak and pine forests. The Levant, the coastal strip of modern Lebanon, Syria, and Israel, was famous throughout the ancient world for the cedar forests of Lebanon, massive trees of great antiquity that provided the timber for the ships and palaces and temples of the ancient Near East. North Africa, which once supported elephants and lions, also had extensive forests along its northern coast that have been almost entirely eliminated. The deforestation of the Mediterranean proceeded through multiple mechanisms over thousands of years. The demands of shipbuilding were enormous. A single warship required hundreds of large trees, and the naval powers of the ancient Mediterranean consumed forests at extraordinary rates. The expansion of agriculture cleared hillside forests for terraced farming. Charcoal production for metalworking and domestic fuel consumed enormous quantities of wood. Goats grazing on deforested hillsides prevented forest regeneration, fixing the landscape in a permanently denuded state. The ecological consequences of Mediterranean deforestation include the thin, eroded soils of many hillsides. The rich forest soils that once covered them have washed into the sea over millennia of bare soil erosion. The rivers of Greece and Turkey run brown with sediment in winter and dry in summer in a pattern unfamiliar to the inhabitants of a more forested Mediterranean. The famous blue clarity of the Mediterranean Sea is partly a consequence of the nutrient poverty created by millennia of soil erosion and forest loss, a beauty built on ecological impoverishment. Fact 84. The lost amphibians, the silent spring of the frog world. In the late 1980s, herpetologists began noticing something alarming at field sites around the world. The frogs were disappearing. Not declining gradually, not showing the slow attrition of habitat loss, but disappearing suddenly and completely, populations that had been abundant and apparently healthy simply vanishing within a year or two, leaving behind empty ponds and silent streams in places where a cacophony of frog calls had been a fundamental feature of the soundscape for millions of years. Investigations eventually identified a fungal pathogen called Batrachochytrium dendrobatides, or BEAD, which attacks the skin of amphibians, but by the time it was identified, the pathogen had already caused what is widely considered the most devastating infectious disease ever recorded in vertebrates. Amphibians, frogs, toads, salamanders, and caecilians are one of the oldest groups of land vertebrates on Earth, their ancestors having colonized the land approximately 360 million years ago. They have survived all 5 of the major mass extinctions. And in the past 40 years, they have suffered a catastrophic global decline driven by the convergence of multiple threats. The BEAD pathogen, habitat loss, climate change, pollution, introduced predators, and the collection of individuals for the pet and food trade. The numbers are stark. Approximately 1/3 of all known amphibian species are currently threatened with extinction, a higher proportion than for birds, mammals, or reptiles. Approximately 90 amphibian species are believed to have gone extinct since 1980, many of them lost with extraordinary speed. The golden toad of Costa Rica, abundant in its cloud forest habitat, and discovered by science only in 1966, was gone by 1989, before researchers had even had time to study it properly. The BEAD pathogen, spread through the global trade in amphibians for pets and laboratories, has caused the complete local extinction of hundreds of populations on every continent where amphibians exist. Amphibians are not merely ecological indicators, though they are among the most sensitive. They are integral members of the ecosystems they inhabit, critical links in the food web between the insects they consume and the snakes, birds, and mammals that consume them, and vital recyclers of nutrients between terrestrial and aquatic habitats. Their disappearance from ecosystems that evolved with them over hundreds of millions of years is a loss with consequences that cascade through food webs in ways we are only beginning to document. Fact 85. The lost forests of the Philippines, a biodiversity hotspot nearly emptied. The Philippine archipelago, 7,641 islands scattered across the western Pacific, is one of the world's most extraordinary centers of biodiversity. Its isolation in the western Pacific, combined with the geological complexity of its islands and the variety of its conditions, has produced a biota of extraordinary endemism. Approximately 60% of the Philippines' terrestrial vertebrate species are found nowhere else on Earth. The Philippine eagle, the Philippine flying lemur, the tarsier, the tamarour, dozens of species of hornbill, and hundreds of plant species found nowhere else share these forests, and those forests are almost entirely gone. At the beginning of the 20th century, the Philippines was covered by approximately 21 million hectares of forest, representing about 70% of the total land area of the archipelago. Today, primary forest covers less than 7% of the Philippines' land area, one of the most dramatic rates of forest loss of any country in the world, driven by commercial logging, agricultural conversion, and the land clearing associated with a rapidly growing population. The deforestation was particularly rapid between 1950 and 1990, when commercial logging effectively stripped the lowland forests from most of the Philippine islands. The Philippine eagle Pithecia jeffrey is one of the most powerful predators in any Asian forest ecosystem, standing nearly a meter tall, with a wingspan approaching 2 meters, and hunting monkeys, large lizards, and other substantial prey. It requires enormous territories of intact forest. A single breeding pair may need up to 100 square kilometers of unbroken primary forest. With the forest reduced to small, fragmented patches, the Philippine eagle population has declined to approximately 800 individuals, and each death from shooting, capture, or habitat loss is a significant blow to a population already too small for long-term viability. Philippines' forests are now among the most fragmented and degraded of any biodiversity hotspot in the world. The species that remain, the tarsiers, the endemic birds, the Philippine crocodile, exist in populations so small and isolated that extinction is a near-term probability for many without sustained, active conservation intervention. The extraordinary biological richness that evolved over millions of years of island isolation is being lost in the span of a single human lifetime. Fact 86. The lost rivers of South Asia, when the Ganges ran clear. The rivers of South Asia, the Ganges, the Brahmaputra, the Indus, the Yamuna, the Godavari, the Krishna, and the dozens of smaller rivers that drain the Indian subcontinent, are among the most sacred, most ecologically rich, and most thoroughly degraded river systems in the world. For thousands of years, they were the lifeblood of one of the world's most ancient and continuous civilizations, providing water for agriculture, transport routes for trade, spiritual significance for religious practice, and habitat for extraordinary biological communities including freshwater dolphins, gharials, giant freshwater stingrays, marcia, and other species found nowhere else on Earth. The Ganges, the most sacred river in Hinduism, regarded as a living deity by billions, carries a pollution load that makes much of its middle and lower reaches biologically unsuitable for the species that evolved in it. Industrial effluents, untreated sewage from hundreds of cities, agricultural chemicals, and religious offerings all contribute to pollution that has eliminated most native fish species from large stretches of the river. The Ganges River dolphin, which once ranged through thousands of kilometers across the Gangetic Plain, has been reduced to fragmented populations, totaling perhaps 3,500 individuals confined to the least polluted river segments. The gharial, a specialist fish-eating crocodilian with an extraordinary elongated snout, one of the most ancient reptiles in South Asia, was once found throughout the rivers of northern India, Nepal, Pakistan, and Bangladesh. Its population crashed to fewer than 200 individuals in the 1970s and 1980s, driven by hunting, sand mining, reduced river flow from irrigation, and fishing nets that drowned individuals. A captive breeding program has partially restored the population to approximately 1,000 individuals, but the river habitats the gharial requires, clear, fast-flowing sections with exposed sandbanks for nesting, are increasingly rare. The rivers of South Asia are not merely ecological systems, they are the physical and spiritual foundation of one of the world's great civilizations, and the ecological degradation they have suffered is also a cultural and spiritual impoverishment. The rivers that are worshipped as deities in one breath are used as open sewers in the next, a contradiction that reflects the extraordinary difficulty of reconciling ancient spiritual traditions with the pressures of a civilization of more than 1 billion people. Fact 87. The lost bees, the vanishing architects of flowering plants. Bees are not merely interesting insects. They are the primary pollinators of approximately 80% of the world's flowering plant species, including approximately 70% of the crop species that feed human civilization: almonds, apples, blueberries, cucumbers, avocados, coffee, and hundreds of other foods that depend on bee pollination for their production. The evolutionary relationship between bees and flowering plants co-evolved over approximately 100 million years, each group shaping the other's form and function, has produced both the extraordinary diversity of flowering plants and the equally extraordinary diversity of bees, and bees are disappearing. The decline of bee populations is one of the most complex and multifactorial ecological stories currently unfolding on Earth. Honeybee colonies have suffered dramatic losses in recent decades through a phenomenon known as colony collapse disorder, in which worker bees mysteriously disappear, leaving behind a queen, food, and a few nurse bees. The causes of colony collapse disorder involve a complex interaction of pesticides, pathogens including the varroa mite, nutritional stress from reduced floral diversity, and climate change. The economic value of honeybee pollination services is estimated in the hundreds of billions of dollars annually. But the crisis extends far beyond honeybees. Wild bee species, of which there are approximately 20,000 species worldwide, are declining across much of their range as wildflower meadows, hedgerows, and other habitats providing nesting sites and diverse pollen and nectar sources disappear from agricultural landscapes. In North America, several species of bumblebee have declined by 90% or more since the 1990s. In Europe, agricultural intensification has reduced the diversity and abundance of wildflowers to the point where many bee species cannot find sufficient food through much of the growing season. The loss of bee diversity is particularly concerning because different bee species pollinate different plant species. A diverse bee community provides more complete and reliable pollination services than a monoculture of honeybees. As wild bee diversity declines, the resilience of pollination networks decreases, and flowering plants that depend on specialist pollinators become increasingly vulnerable to pollination failure. We are systematically dismantling the pollination infrastructure that sustains both natural ecosystems and human food systems. Fact 88: the lost forests of West Africa, the cradle of primates almost gone. The forests of West Africa, stretching across Guinea, Sierra Leone, Liberia, Ivory Coast, Ghana, and their neighbors, are among the most biologically important tropical forests on Earth. This region is the evolutionary cradle of the great apes. Chimpanzees and their close relatives evolved here, and from West African primate populations, genetic analysis suggests the ancestors of humans ultimately derived. The West African forests are the homeland of western chimpanzees, western lowland gorillas, pygmy hippos, forest elephants, colobus monkeys, drill baboons, and hundreds of endemic species. They are also among the most heavily deforested regions on the planet, reduced to fragments so small that the populations of great apes surviving in them are, in many cases, too small to be viable over the long term. The West African forests have been reduced to approximately 15 to 20% of their original extent by a combination of forces including commercial logging, agricultural expansion, charcoal production, and the bushmeat trade. The ivory trade eliminated forest elephant populations from most of their former range in West Africa, and remaining forest elephant populations are tiny and fragmented, with some estimates suggesting fewer than 100,000 forest elephants survive across the entire Congo Basin and West African region combined. Western chimpanzees have declined by approximately 80% in the past 30 years and are listed as critically endangered. Their decline reflects the convergence of habitat loss, bushmeat hunting, and the capture of infants for the pet and entertainment trade. Guinea, which retains some of the largest remaining areas of intact forest in West Africa, is currently facing major threats from industrial mining, bauxite extraction, and agricultural development that could eliminate the last significant forest areas in the subregion. The West African forests are the forests that shaped our evolutionary ancestry, the landscapes in which the lineage that led to modern humans lived for millions of years, in which the cognitive, social, and physical traits that distinguish our species were selected and refined. Their destruction is the destruction of the evolutionary context in which humanity emerged, a loss that extends beyond the ecological into something much more fundamental about our identity as a species. Fact 89: the lost savannas of Australia, grasslands without their architects. Australia's tropical and subtropical savannas, stretching across the northern third of the continent, from the Kimberley of Western Australia through the Northern Territory to Queensland, form the world's largest remaining tropical savanna ecosystem, covering approximately 1.9 million square kilometers. This enormous landscape supports a remarkable diversity of wildlife, including freshwater crocodiles, wallabies, quolls, numerous endemic birds, and billions of insects. But the Australian savannas are changing, driven by the absence of an ancient ecological engineer whose role in maintaining the savanna has only recently been fully appreciated. For at least 65,000 years, the Aboriginal peoples of Northern Australia managed the savanna landscape with fire, a practice known as caring for country, in which small mosaic fires were lit deliberately throughout the year to maintain a patchwork of differently aged vegetation, prevent the buildup of fuel that leads to devastating uncontrolled fires, and create the habitat conditions that favored the animals and plants Aboriginal communities depended on. This mosaic burning created a heterogeneous landscape of recently burned and unburned patches that maintained the ecological diversity of the savanna far more effectively than the infrequent but catastrophic fires that occur when fuel accumulates unchecked. The displacement of Aboriginal communities from much of Northern Australia's savanna country in the 19th and 20th centuries removed this mosaic fire management. The result has been a dramatic change in fire regimes. Large, infrequent, catastrophic fires have replaced the small, frequent, mosaic fires of traditional burning practice. Long unburned areas accumulate fuel loads that produce intense fires, killing the hollow-bearing trees that provide nesting habitat for parrots and possums. The heterogeneous mosaic of vegetation maintained by traditional burning has been replaced by large blocks of uniform vegetation, less diverse in structure and ecological function. The recognition that Aboriginal fire management was maintaining the ecological character of the Australian savannas has led to programs supporting the return of Indigenous fire managers to Northern Savanna country, programs that have demonstrated measurable ecological benefits where cultural burning has been reinstated. The savanna still exists. The knowledge of how to maintain it still exists in some communities. The challenge is whether the support for restoring that relationship will come in time. Fact 90. The lost languages of the natural world. Ecological knowledge disappearing. There is a form of knowledge about the natural world that is not written in any scientific journal, not encoded in any DNA database, not preserved in any museum specimen, knowledge that exists only in the minds of the people who carry it, passed from generation to generation through languages and oral traditions that are themselves disappearing alongside the ecosystems they describe. This is the ecological knowledge encoded in the world's indigenous languages, the detailed understanding of local ecosystems, species behaviors, plant properties, and environmental change accumulated by human communities living in close relationship with specific natural environments for centuries. As the world's languages disappear at a rate of one language every 2 weeks, this knowledge vanishes with them. There are approximately 7,000 languages currently spoken in the world. Linguists estimate that approximately half will be gone by the end of this century, their last speakers dying without passing them on. Many are indigenous languages spoken by small communities in biologically rich regions. The Amazon basin, the islands of the Pacific, the forests of Africa, the mountain valleys of Papua New Guinea, communities whose ecological knowledge is most distinct from that encoded in Western scientific literature, representing thousands of years of observation in specific ecosystems that Western science has often barely begun to study. Indigenous ecological knowledge has, in many cases, significantly advanced scientific understanding of the natural world. The pharmacological properties of hundreds of plant species, now used in pharmaceutical products worldwide, were first identified through the traditional medical knowledge of indigenous communities. The seasonal behaviors of fish, the migration patterns of birds, the locations of freshwater sources, the early indicators of weather change, all recorded in indigenous knowledge systems with a precision that scientific research has sometimes taken decades to match. When a language dies, the ecological knowledge it carries does not simply shift into another language. The specific vocabulary for describing relationships between species, the place names that encode information about where certain plants grow or certain animals congregate, the narrative structures that transmit ecological knowledge across generations, all of these are lost with the language itself. In losing the world's indigenous languages, we are losing not only cultural heritage, but an irreplaceable archive of human observation of the natural world. 90 worlds, 10 remain. You have traveled from the ancient oceans of the Cambrian to the forests where our ancestors evolved, from the first oxygen in the atmosphere to the last speakers of languages that name the world in ways no other language can. Let the final 10 worlds come to you in the last of the night. This is explored during sleeping. You have arrived at the final part of the journey. 90 worlds behind you, 10 ahead. The night is at its deepest, that still hour before the first hint of dawn when the world seems to hold its breath. In this 10th and final part, we come to the deep ocean reefs, the melting Arctic, the savannas of Brazil, the acoustic world of the sea, and the long arc of what has been lost and what might still be found. This is explored during sleeping. Fact 91. The lost coral reefs of the deep, forests beneath the dark water. When most people think of coral reefs, they picture the sunlit shallow water reefs of the tropics, the Great Barrier Reef, the Red Sea, the Caribbean, vast gardens of color and life in warm, clear water. But corals do not only build their extraordinary structures in shallow, sunlit water. Deep beneath the surface, in water too cold and dark for photosynthesis, there exists an entirely different world of coral. The cold-water coral reefs, built by species that feed by filtering organic particles from the slow, cold currents of the deep ocean. These deep-water coral reefs are among the most ancient, biologically diverse, and least known ecosystems on Earth, and they are being destroyed faster than they are being discovered. Cold-water corals have been documented at depths ranging from 40 meters to over 6,000 meters below the ocean's surface, on the continental shelves and slopes, and on the submerged peaks of seamounts throughout the world's oceans. They grow extraordinarily slowly. Some cold-water coral colonies are estimated to be over 8,000 years old, making them among the oldest living structures on Earth. The reef structures they build over centuries and millennia provide habitat for an extraordinary diversity of species. Fish, crustaceans, echinoderms, and mollusks cluster in the complex architecture of the deep coral reef in densities that rival the richness of shallow tropical reefs. The primary threat to cold-water coral reefs is deep-sea bottom trawling, the industrial fishing practice of dragging heavy-weighted nets across the seafloor to catch bottom-dwelling fish such as orange roughy, Patagonian toothfish, and other commercially valuable species. A single pass of a bottom trawl can destroy in minutes a coral reef structure that took centuries to grow, reducing it to a field of coral rubble. In the North Atlantic, studies of seamount ecosystems have found that areas subject to bottom trawling have lost 80 to 99% of their coral cover compared to unfished areas. The deep-sea coral reefs represent an ecological world almost entirely beyond human experience, dark, cold, and impossibly remote, visible only through the cameras of deep-sea submersibles. Their extraordinary age, their biological richness, and the millennia of growth they represent have been destroyed in the past 50 years of industrial deep-sea fishing. Many of them were gone before science had even found them. Fact 92. The lost savannas of Brazil, the Cerrado's hidden richness. The Cerrado, the vast tropical savanna of central Brazil, covering approximately 2 million square kilometers across the Brazilian plateau, is one of the world's most biologically diverse ecosystems and one of its least celebrated. While the Amazon rainforest to the north attracts global conservation attention and international concern, the Cerrado has been converted to agriculture at a staggering rate with relatively little international notice, losing approximately half of its original extent to soybean cultivation, cattle ranching, and sugar cane production in the past 40 years. The Cerrado is the most biodiverse savanna on Earth, and it is disappearing without the world watching. The biological richness of the Cerrado is extraordinary and largely invisible to people unfamiliar with the ecosystem. The Cerrado contains approximately 5,000 plant species found nowhere else on Earth, along with unique fauna including the maned wolf, the largest canid in South America, with legs so long it seems to walk on stilts, the giant anteater, the giant armadillo, the marsh deer, and the pampas cat. The rivers that rise in the Cerrado feed the three largest river basins in South America, the Amazon, the Paraná, and the São Francisco, making the Cerrado's water cycle of critical importance to the entire continent's freshwater supply. The Cerrado has also been called the upside-down forest because its plant communities store the majority of their biomass underground rather than above it. The deep, woody root systems of Cerrado plants, adapted to survive the dry season and the frequent fires that maintained the savanna ecosystem for millions of years, extend many meters into the earth, storing carbon in the soil and providing the hydraulic infrastructure that draws water up from deep aquifers and releases it through transpiration into the atmosphere, feeding the cloud systems that deliver rainfall to the Amazon and to the agricultural regions of southern Brazil. The conversion of the Cerrado to agriculture has disrupted this underground ecology in ways that are difficult to measure but profound in their consequences. The loss of the deep-rooted Cerrado vegetation has reduced the water cycling that maintains regional rainfall patterns, contributing to drought conditions that are increasingly affecting both the remaining Cerrado and the agricultural land that has replaced it. The savannas of Brazil are not merely a local concern. Their loss is changing the climate and water cycle of an entire continent. Fact 93. The lost Arctic Ocean, the sea ice world melting away. For at least the past million years, and probably much longer, the Arctic Ocean has been covered by sea ice in all seasons. The permanent ice cover of the central Arctic surrounded by a seasonal fringe that grew and shrank with the cycle of polar night and polar day. This sea ice is not merely frozen water. It is an ecosystem, a habitat, a hunting ground, a breeding platform, and a fundamental component of the Earth's climate system. The loss of Arctic sea ice, already well underway and accelerating, is one of the most dramatic and consequential environmental changes occurring anywhere on Earth, with implications that extend far beyond the Arctic itself to the climate of the entire Northern Hemisphere. The Arctic sea ice ecosystem supports a food web of extraordinary complexity built on ice algae, microorganisms that live within the ice and on its underside, forming the base of a food chain that includes crustaceans, fish, ringed seals, bearded seals, walruses, polar bears, beluga whales, narwhals, bowhead whales, and Arctic foxes. The seasonal cycle of sea ice advance and retreat drives the timing of breeding, migration, and feeding for all of these species. And the loss of sea ice is disrupting the biological rhythms that these animals' entire life histories have been built around. The polar bear has become the symbol of Arctic sea ice loss, but it is only the most visible of many species facing existential threat from a melting Arctic. Ringed seals give birth in snow layers on the sea ice and nurse their pups there. As sea ice becomes thinner and more unstable in spring, the layers collapse and pups die. Walruses, which use sea ice as resting platforms between dives to the shallow seafloor where they feed, are being forced ashore in massive aggregations as the ice retreats, causing deadly stampedes when panicked animals rush off cliff tops into the sea. The Arctic Ocean could be functionally ice-free in summer within the next decade to 2 decades, a state that has not existed for approximately 3 million years. The ecosystem built around Arctic sea ice over millions of years of evolution cannot simply adapt to an open Arctic Ocean in the space of a generation. The Arctic is becoming a different ocean, and the creatures that evolved for the world of ice are becoming the inhabitants of a world that no longer exists. Their fate is a mirror of a planet changing faster than life can follow. Fact 94. The lost grasslands of Central Asia, the steppe empire transformed. The Eurasian steppe, the vast belt of grassland stretching from Hungary in the west to Manchuria in the east, covering approximately 13 million square kilometers of temperate grassland across Russia, Kazakhstan, Mongolia, and neighboring countries, is one of the world's great grassland ecosystems, historically supporting an extraordinary diversity of wildlife including saiga antelopes, Piarziulskis horses, steppe eagles, demoiselle cranes, and the vast populations of rodents and insects that form the base of the steppe food web. It is also the birthplace of horse domestication and the ecological context in which the nomadic pastoralist cultures of Central Asia, the cultures of the Scythians, the Huns, the Mongols, developed their distinctive ways of life, and it is changing dramatically. The saiga antelope, a strangely beautiful animal with a bulbous overhanging nose that filters dust and warms cold air before it reaches the lungs, once existed on the Eurasian steppe in tens of millions of individuals, forming herds so large that early European travelers described the landscape as appearing to move when a saiga herd was on the march. By the early 21st century, overhunting following the collapse of the Soviet Union had reduced the global saiga population to approximately 50,000 individuals, a decline of more than 95%. Subsequent conservation efforts have allowed partial recovery, but in 2015, a bacterial disease killed approximately 200,000 saiga, roughly 60% of the then current population, in a matter of weeks. The conversion of the Eurasian steppe to agriculture, particularly intensive during the Soviet era, when the Virgin Lands campaign of the 1950s plowed enormous areas of Kazakhstani steppe for wheat cultivation, has permanently transformed millions of square kilometers of grassland. The Aral Sea disaster, which we explored earlier in this journey, was partly a consequence of this agricultural expansion and the diversion of the rivers that fed it. The steppe is also under pressure from mining, oil and gas development, and the disruption of the traditional nomadic pastoralism that had maintained the grassland ecology for thousands of years. The nomadic cultures of Central Asia, whose seasonal movements of vast herds across the steppe created the grazing patterns that maintained the grassland in a state of ecological health, are increasingly sedentary, their traditional land management practices replaced by more intensive and less ecologically sensitive forms of land use. Fact 95. The lost forests of New Caledonia, ancient Gondwana survivors. New Caledonia, a French territory in the southwestern Pacific, approximately 1,500 kilometers east of Australia, is one of the most extraordinary islands in the world from a biological perspective. Isolated from other landmasses for approximately 80 million years, since the breakup of the ancient supercontinent Gondwana, New Caledonia has served as a biological museum, preserving plant and animal lineages that have gone extinct everywhere else on Earth. The island's forests contain some of the most ancient flowering plant families in the world, including the Amborella, a shrub considered to be the closest living relative to the ancestor of all flowering plants, a living link to the origin of the most dominant group of plants on the modern Earth. New Caledonia's forests are estimated to contain approximately 3,370 plant species, of which approximately 75% are endemic, found nowhere else on Earth. This extraordinary level of plant endemism is comparable to the most biodiverse tropical regions on the planet, despite New Caledonia's relatively small area. The island's fauna is equally remarkable. It was the home of a diverse community of large flightless birds, including the world's largest known pigeon and several species of giant rails, before human settlement approximately 3,000 years ago triggered the wave of extinctions that has affected virtually every Pacific island. New Caledonia's forests are under threat from nickel mining. The island sits atop the world's largest deposits of high-grade nickel ore, and mining has cleared approximately 10% of the island's original forest cover, with significant additional areas damaged by the runoff of mining debris. The destruction of New Caledonia's forests is the destruction of 80 million years of evolutionary continuity, the loss of biological lineages that survived the mass extinction that killed the dinosaurs, that survived the dramatic climate changes of the ice ages, that have persisted through the entirety of the modern era of mammalian evolution. The Amborella, that living link to the origin of all flowering plants, grows in the montane forests of New Caledonia and nowhere else. If the forests of New Caledonia are destroyed, the Amborella goes with them. And with the Amborella goes a living window into the origin of the flowering plants that have dominated the Earth's vegetation for the past 100 million years. Fact 96. The lost freshwater fish, rivers running empty of ancient lineages. Freshwater fish are among the most threatened vertebrates on Earth. Although freshwater environments cover less than 1% of the Earth's surface, they are home to approximately 1/3 of all vertebrate species, an extraordinary concentration of biodiversity, reflecting millions of years of evolutionary diversification in the rivers, lakes, and wetlands of every continent. And this extraordinary concentration of biodiversity is in catastrophic decline. Freshwater fish populations have declined by an average of 76% since 1970, according to the Living Planet Index, and freshwater vertebrates overall are declining at twice the rate of marine or terrestrial vertebrates. The rivers of the world are home to an extraordinary diversity of freshwater fish species whose existence is unknown to most people. The blind cave fish of Mexico, Kentucky, and Madagascar, who evolved in complete darkness and lost their eyes over millions of years of cave life. The paddlefish of the Yangtze and Mississippi rivers, filter feeders whose relatives swam alongside dinosaurs. The arapaima of the Amazon, one of the largest freshwater fish in the world, reaching 3 meters in length. The hundreds of species of cichlid fish in the African Great Lakes, whose rapid speciation has produced more new species in a shorter time than almost anywhere else on Earth. The threats to freshwater fish are the threats to freshwater ecosystems generally: dams that block migration routes, water extraction that reduces river flows, pollution from agriculture and industry, the introduction of invasive species, and climate change that alters the temperature and seasonality of rivers. But the effects on freshwater fish are particularly acute because freshwater fish, unlike terrestrial or marine species, are literally imprisoned in their habitats. A fish in a river that is dammed, diverted, or polluted cannot simply move to a nearby river. The barriers between watersheds are absolute, and there is no escape route. The loss of freshwater fish is a loss that is invisible to most people. The rivers continue to flow. The water continues to look like water. But rivers that were once alive with dozens of fish species are now effectively biological deserts, their endemic fish either gone or reduced to remnant populations too small to persist. The rivers are still there, the fish are not. Their silence is the silence of something that cannot speak for itself, and that we are losing before we have fully understood what we had. Fact 97. The lost megafauna of Madagascar, the island at the edge of extinction. Madagascar, the fourth largest island in the world, separated from the African mainland approximately 88 million years ago, is one of the most biologically remarkable places on Earth. Its long isolation has allowed the evolution of a fauna of extraordinary uniqueness. Approximately 90% of Madagascar's wildlife is found nowhere else on Earth. The lemurs, the most ancient living primates, whose ancestors colonized Madagascar from Africa approximately 60 million years ago, have diversified into over 100 species, filling the ecological niches occupied by monkeys, squirrels, and other animals elsewhere. The fossors, the tenrecs. The mongooses, the baobab trees, Madagascar's ecology is unlike anywhere else in the world. We touched on Madagascar's lost megafauna earlier in this journey, the elephant birds and the giant lemurs that went extinct following human arrival approximately 2,000 years ago. But what we have not fully explored is the scale of what was lost. The largest of the giant lemurs, Archaeoindris, was the size of a male gorilla, and it went extinct sometime in the past 2,000 years. The smaller giant lemurs, Megalodapes, Paleopithecus, and their relatives, filled ecological roles comparable to large browsing mammals elsewhere, and their disappearance restructured the entire vegetation of the island. The sloth lemurs browsed in trees in the manner of large sloths. The koala lemur occupied a niche similar to that of its Australian namesake, all gone. The devastation of Madagascar's wildlife has not stopped with the megafauna. Today, Madagascar is one of the most biodiversity-threatened places on Earth, with approximately 90% of its original forest cover gone, reduced by slash-and-burn agriculture, charcoal production, and commercial logging to small fragments largely confined to the eastern escarpment and protected areas. Of the lemur species that survived the megafauna extinction, approximately 95% are now threatened with extinction, making lemurs the most endangered group of mammals on Earth. Madagascar is a case study in what happens when a biologically unique island meets the pressures of poverty, population growth, and inadequate governance. The extraordinary biological wealth accumulated over 88 million years of isolated evolution is being lost within the span of a few human generations, a loss that represents not just the extinction of species, but the erasure of an entire evolutionary experiment that cannot be replicated anywhere on Earth. Fact 98: the lost pollinators beyond bees, butterflies, moths, and hoverflies vanishing. We have already explored the catastrophic decline of bees in this journey, but the crisis of pollinator decline extends far beyond the bees to encompass the butterflies, moths, beetles, hoverflies, and other insects that together form a complex and redundant network of pollination services on which both natural ecosystems and human agriculture depend. As agricultural landscapes have been simplified, pesticide use has intensified, and wildflower-rich habitats have been eliminated from the farmed countryside, these pollinator communities have collapsed across large areas of the temperate world, with consequences that are only beginning to be understood. Butterflies are among the most visible and best monitored of all insect groups, and the data on their decline is particularly alarming. In the United Kingdom, butterfly populations have declined by approximately 46% since the 1970s, with grassland and farmland species showing the most dramatic losses. In the United States, the monarch butterfly, whose annual migration from Canada to the mountains of central Mexico is one of the most spectacular biological phenomena in North America, has declined by approximately 80% in its eastern population since the 1990s, driven by the widespread adoption of herbicide-resistant crops that have eliminated the milkweed on which monarch caterpillars exclusively depend from vast areas of the agricultural Midwest. Moths, the largely nocturnal relatives of butterflies, far more numerous in species and ecological importance, but far less visible and celebrated, have declined even more dramatically than butterflies across much of Europe and North America. In the United Kingdom, the total abundance of moths has declined by approximately 50% since 1968. Moths are the primary pollinators of many plant species that open their flowers at night, and they are the primary prey of bats and nightjars, whose own populations are closely tracked to moth abundance. The loss of these pollinator communities is a loss of the intricate ecological relationships that evolved over hundreds of millions of years between flowering plants and the insects that pollinate them. As pollinator diversity declines, the networks of plant-pollinator interactions become simpler and more fragile, less capable of absorbing the disruptions of climate change and other environmental stresses. The extraordinary diversity of the world's flowering plants was built by pollinators. Without them, it cannot be maintained. Fact 99: the lost ocean sounds, silencing the acoustic world of the sea. The ocean is not silent, it never was. The pre-industrial ocean was alive with sound, the low, resonant songs of blue and fin whales, audible to other whales across thousands of kilometers of open ocean, the clicking and whistling of dolphin pods, the snapping of shrimp in reef ecosystems, the spawning calls of fish, the songs of humpbacks, complex and ever-changing, echoing through entire ocean basins in patterns whose meaning we still do not fully understand. The acoustic world of the ocean was ancient, complex, and full of biological meaning, a medium through which marine animals navigated, communicated, and found each other in a world where sight is limited by distance and depth. And then, with the rise of industrial civilization, we filled the ocean with noise. Anthropogenic ocean noise, the noise generated by shipping, by sonar, by offshore construction, by seismic surveys for oil and gas exploration, has increased dramatically in volume and geographic extent since the mid-20th century. The noise from large container ships spans the low-frequency range used by baleen whales for long-distance communication, and the global shipping fleet has doubled in size multiple times since the 1950s, creating a level of low-frequency noise that now saturates much of the deep ocean. The effective range over which a blue whale can communicate with another blue whale has been estimated to have decreased by a factor of 10 or more compared to the pre-industrial ocean. The consequences of ocean noise pollution for marine life are profound and poorly documented. Whales exposed to intense sonar have stranded in mass strandings, their ears damaged and their behavior disrupted. Fish exposed to high-intensity noise show disrupted spawning behavior, reduced hearing sensitivity, and elevated stress responses. Invertebrates including shrimp, squid, and scallops show physical damage and behavioral disruption in response to seismic air guns. The ecological consequences of degraded acoustic communication across entire ocean populations are unknown but likely substantial. The ocean soundscape that existed before industrial civilization was one of the Earth's great unwitnessed natural phenomena, a global acoustic network of biological communication stretching across every ocean basin, carrying information across distances that no other medium could bridge. It has been overwritten by the sounds of commerce, and the marine animals that evolved to use it must now navigate an ocean that no longer sounds like the ocean they evolved for. Fact 100: the lost futures and the worlds that could still be saved. We have journeyed now through 100 worlds, from the ancient seaways of the Cambrian to the vanishing butterflies of today, from the forests that covered Antarctica to the languages that name the world in ways no other language can. We have traveled through geological time and human time, through worlds that ended with meteor impacts and worlds that ended with chainsaws, through extinctions triggered by the first oxygen in the atmosphere and extinctions triggered by the last drop of freshwater in a vanishing lake. 100 worlds, gone or going. And the journey has been, in its way, a kind of grief. A grief for the richness and complexity that the Earth once held, and still holds in diminished and fragile form, and that is passing from existence faster than at any time since the mass extinction 66 million years ago that ended the age of the dinosaurs. But grief is not the only response available to the knowledge that this journey has brought. Every world we have visited that is still in the process of being lost, the Congo forest, the coral reefs, the Arctic sea ice, the freshwater dolphins, the indigenous languages, the night sky, is a world that is still here, partially, imperfectly, in need of help. The restoration of wolf populations in Yellowstone, restored river courses and revived forests, and increased biodiversity across an entire ecosystem. The recovery of humpback whales from commercial whaling shows that even severely depleted populations can rebuild. The return of indigenous fire management to the Australian savannas shows that ecological relationships severed for a century can be restored. The world that exists today is not the world of a century ago, and it is not the world of 1,000 years ago. And it is certainly not the world of 1,000,000 years ago, but it is still a world of extraordinary richness, of forests and rivers and oceans and species that have no analogue anywhere else in the known universe. The Earth remains the only place we know of where life has created a biosphere of this complexity and beauty, a 4 billion-year experiment in diversity and interconnection that has survived 5 mass extinctions and is now navigating its way through the 6th. You have traveled far tonight, through the deep of time and the deep of the night. The worlds that were lost are gone, but they are not forgotten. They are part of the story of this planet, and their loss has something to teach us about what we still have and what we still might save. Sleep now. The journey is complete. This has been explored during sleeping. 100 worlds. You have traveled through 4 billion years of life on Earth, from the first living cells to the last blue whales still singing in an ocean that no longer sounds the way it did when they learned to sing. The sun will rise soon. The world will still be there, diminished, fragile, extraordinary, and worth every effort to protect. Thank you.